All right, so before I start, I just want to do a quick recap of what we did yesterday because I know there are some people here that joining for the first time and maybe you might know what a circle is. I hope you would know what a circle is, but if you don't know, that's okay. We're gonna run through it back today. Let me just fix this setup. All right. By the way, are you willing to go to 12 o'clock tonight? I didn't know I'm crazy by now. I would do that.
Yes, we can go to 12, it's no problem.
We just we
I will
just
tell them
outside,
that.
outside, boy, we outside. Say no more, right? So what exactly is a circle? Guys, is this a circle? I just tested any waters. Is that a
No.
circle?
No, sir.
No. This is a circle,
No.
right? This is a circle.
Yeah.
That blue thing that you're seeing, right? What do we call this? What do we call that? Like if you
The circumference.
right, you would call this the circumference. Right, this is the circumference. What would I call this black dot over there? What is that? What is that?
The center.
That's the center, right? We know that. You can see the center of the circle. What if I draw a line from the center to a point along the circumference? What would I call that?
The radius.
I have a question, guys. If I say that our radius is 5 centimeters, right? If I say that is 5 centimeters, what would that length be?
5 centimeters.
5 centimeters.
Right. 5 centimeters. What you need to know is the radius is the same. All the radii are the same per circle. If it wasn't, it'll look like a potato, right? It'll look like a potato. Enter circle is perfectly round. And the reason for that is because the radius is the same everywhere, right? Remember that. What if I had a line going from one end to the circumference, passing through the center, and touching the other end of the circumference? What would I call that?
10 meters. 10 centimeters.
Diameter.
Right, this is the diameter. All right. Okay, let me move on to some harder things that you're probably not familiar with. Let me just draw a new circle. And by the way, guys, as you know, I'm sending this right after the live. I'm sending it right after the live. What if the line goes from one end to the circumference, right, to the other end, but it does not pass through the center? What would you call that?
A chord.
Guys, and let me show you that easy way to remember this, right? What are chords do in real life? If I ask you what chords do, what does a chord do in real life?
Connect two things together.
Guys, exactly right. Look my charger over here. What does this do? This is connect my phone to the outlet, right? So what the cord doing, it connected one end of the circumference to the other end. Cord. Makes sense. Right? That makes sense. This is the cord. Now, I'm gonna throw in something here, right? What if the line passing from one end to the other end, but also coming out of the circle? What
Isn't
do
it secant?
Secant.
Yes. I remember, big up on yourself. Let me go. Right? So we call this the secant, right? Not to be confused with the chord. Just to make sure all you understand, what would I call this? What do you think I would call that?
Minor segment.
No.
Secant.
I would call that a secant. Right? Because guys, watch. It's okay. It touching this end of the circumference, but on the other side, it extending outside of the circle. So it's still a secant, right? Still a secant. But on the other side, it. I'm hearing real echoing. Somebody. Okay, I'm not hearing any echoing anymore. Let me just check who here. Adika, good night. We outside tonight?
Good night, yeah.
Boy, that we talking about. So you're here till 12 o'clock then, that we're saying.
Yeah, I don't mind.
Right. So love to hear that. Who else here that I know? Anuradha. Nice seeing you again. Camille, big up yourself. Ivan, Carissa, Mati, I think that's your name. Nikolai. Who else here that I know?
Matai.
Matai. Okay. Right, Matai. Is that why you put the H in capital letters to enunciate the pronunciation?
Yeah, but my real name is Matthias.
Matthias. Okay, okay. Well, nice to meet you. And you was there yesterday and just said your brother put you on to me.
Yeah.
Okay, well,
So,
glad to have you back. Ivan, you there? I see you asking my question.
Here's the fact, right? I have a sister in Trinidad. Yeah.
Yes. Okay.
You heard me? Yeah.
Your sister in Trinidad.
Yeah.
Okay, cool. Well, tell she about math vibes, right? Okay.
Yeah, all right.
Let us move on to some other things, right? Okay. So let me get another circle. Get another circle now. Trick question. What do you think this is?
accord.
Happy that you say accord, right? Why is the answer accord, guys? Why is it not a diameter? Somebody tell me.
Because
Because we don't know
the-
for sure that that's the center.
Yeah, we don't know that. So by definition, this is a chord, right? This is a chord. So a chord cuts a circle into two portions. Guys, if this was a pizza, which portion are they eating? Portion one or portion two?
Portion two.
A little greedy boy.
Two.
1 and 2.
I gonna be looking like Santa Claus after Christmas, boy. I believe gonna be popping. Way boy. Imagine how much ham I gonna eat. Right? So the smaller, so in maths, like in particularly in this topic, when we're talking about smaller, we're gonna call that minor, right? And when we're talking about bigger, right? We are talking about major. So you see how the chord cuts in the circle into different portions? I would call this a segment. But guys, is it the smaller segment or the bigger segment?
Smaller.
Is the smaller segment, right? So let me just shade this. So what would I call this segment?
Minor.
Minor.
Right, I'd call this the minor segment. And what would I call the other segment?
Major.
Major segment, nice. Major segment. Cool. All right, let's move on to something else. Let's just say this was our pizza. By the way, guys, I say in Pizza Hut is the best. You can fight more on that. I think Pizza Hut is the best.
So you're talking mad.
I
Real
know
Pizza Hut is the best.
Hey, all you know that stuffed crust pizza. Oh God. I'll get hungry. Let me shut up. Get hungry. Right? So if you have two radii, right? It's going to cut a slice of the circle, and that slice, do you all know what we call that slice?
Sector.
A sector, right? So we call this a sector. This is a sector. Right? And I have a question, guys. Isn't this also a sector by definition?
Yes.
Now remember what a sector is, right? A sector is a shape made by two radii and the outer length, right? The arc length. So my question is, guys, check this, right? Check this out for a bit. So you see how the two radii cut a slice out of the circle? It formed an arc. Now, an arc is just a piece of the circumference. So, guys, when I cut a slice out of the circle, I end up with this arc, right? This arc over here, and I ended up with this arc. Which one are you think bigger? One or two?
Two.
So, guys, so if I want to label this arc over here, what would I call that arc? The major arc or the minor?
Minor.
I'll call it the minor arc. And another question, right? This entire thing over here, I would call that. First of all, what's this? What's that? What's with S?
Sector.
A sector, right? It's a sector. A sector. Is it a minor sector or a major sector? What do you all think?
Minor sector.
Minor sector, right? Okay. What do they think this pink, that pink area is? What would I call that?
Major sector.
Major sector.
Right? And this very, very poorly drawn, I swear guys, that is actually drawn in real life. I don't know what happened here. But this pink outer length. What would
Minor. I mean major.
this is a major arc, right? This is a major arc. Okay. So everybody all right with the properties of a circle so far? Yeah? When I follow, okay with the properties of the circle so far?
Yes, sir.
All right. Trick question. What would I call this? Would I call that a sector?
No.
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 No, I wouldn't call it a sector, right? Because okay, for a region to be called a sector, right? It needs two radii, it needs to actually enclose the area. So we see how we have one radius over here and we have another radius over here, right? That encloses a region, and that's the sector, right? And we have the same thing going on over here. So this is another sector. However, you can't say this is a sector. Guys, is this the center of the circle?
No.
No,
No.
sir.
No, that can't be the center, right? Can't be the center. All right, so these are the basic properties of our circle. I want to take a screenshot before we move on. Oh, and we have some other things to go through.
Yeah.
You know where's the tangent? You know where's the tangent?
Yes, sir.
Yes, sir.
I have a question then. Tell me, would this be a tangent?
No, sir.
No.
What would I call that?
A secant.
That's secant. What would I call this? Wait, what would I call this?
Tangent.
A tangent.
Right, this is our tangent. Now, a tangent touches the circle at how much points?
1.
One.
Right. The secant touches the circle how much times?
2 points.
2 times, right? Great. What would that be?
A secant.
Tangent.
Somebody said a secant, somebody said a tangent. Let me hear somebody, another person to break the
A secant.
Yes.
Secant.
It's a secant. Although if we zoom into this, let me be real. Wait, I have a perfect sticker for this. Wait, right? If we look at this thing, right? Like we really look at it. How much times I cut in the circle?
2 times.
5.
Exactly. That can't be, guys. No, that can't be a tangent, right? That's actually a secant. That would be a tangent. Are you understand?
Yes, sir.
Yes, sir.
Right. So take a screenshot of the basic properties, right? Let me just fix something here. Right. Guys, all I hear the Timu notifications just now. All I hear that just now, the Timu notifications. I'm gonna take it as no, as like a little thing. All right. So this is the major sector. All right. So I want us to take a screenshot of this. All right. So you'll know when you hear me say words like chord, arc, you wouldn't be confused. So take a screenshot of this. And guys, if you're in the group chat, the WhatsApp group chat, take a screenshot, put it on the group chat. Do that favor for me. Right? So everybody go have it. Yeah, guys. So when I had the screenshot, tell me, right? I'm gonna move on. Okay, I'm going to move on. Gonna move on. So to make our life simple, I have something for you. A little gift. Like you see, I dress up like Santa Claus here. All right, I don't have the belly though. I don't want the belly. But I have a little gift for you. All right. Circle theorem. I have a nice little diagram with everything you're supposed to know right? When it comes to circles. So I'll go take a screenshot of this. Obviously, we will go through them in detail, don't worry, right? But
I don't know if they are going to take a screenshot there.
yeah, take a screenshot. Take a screenshot of that. All right. And again, don't be selfish. If you take a screenshot, pay it in the group chat. Pay it in the group chat. Nice. Do that. So when you have a screenshot, let me know, and we will move on. Guys, I don't bite. Like I say, I have big teeth, but I don't bite. So like, if you take a screenshot and you already have it, unmute and tell me. So I will know what's going on.
Yes, sir.
Okay, cool. So let's look at the first theorem. I want somebody to read this. Let me call on somebody that I probably never hear from before. Who I never hear from at all. Fadila Wahab. I probably slaughtered your name. I'm very sorry. But I'd like you to give this a read for me. Don't feel shy. It's vibes here. Give this a read. Okay. I'm not hearing that person. Here, what? Adika. Give this a read for me. Give it a read for me, Adika.
Angles in the same segment and standing on the same chord are always equal.
So let's try to understand what they are saying. Right? Adika, do we know what a segment is?
Yeah.
Okay, so let me ask you a question, right? What is the green line called? What would I call the dark green line? Tell me, what's that?
A chord?
That's a chord. And the chord would cut the circle into two portions, right? So what would I call this?
The major segments.
Right, I'd call that the major segment. And what would I call this?
The minor segments.
Correct. Are these two angles in the same segment?
Yeah.
Yeah, and all of us could see that if this chord cutting the circle into two portions, and this angle, all of them in the same segment, right?
Yeah.
So we could see that. Next thing, are both of the angles standing up on the same chord or arc? When I say
Yes.
stand up, this is what I mean, right?
Yeah.
Imagine this is our leg, right? There's our head. I don't know what kind of person that is, but let me just say that's our head and that's legs, right? As you can see, they're standing up on that chord, right? Same situation over here. This angle is standing up on this chord. So the rule goes like this. Angles in the same segment and standing on the same chord are always equal, right? So guys, if I knew that this was 50 degrees, how much degrees would this be?
50.
50 degrees as well.
50.
50, right? Let's do a quick question. Do a quick question, right? All right, let me call this O, let me call this A, let me call this B, and let me call this C. All right. So guys, let me just say we knew that this was, I don't know, 47 degrees. What do you think this would be?
47 degrees as well.
And why is that? Why is that? See if you can remember the theorem, because they want the theorem in the exam. Trust me, if you don't put the theorem, you're going to lose marks. So what's the theorem for this?
Angles standing on the same chord always equal. The angles always equal.
You forget one thing, right? Chord OA cuts the circle into two segments, right? You're supposed to say that both of them standing up on the same chord and they are in the same segment, so they're equal. Understand?
Yes, sir.
So let me just write that down. So you would say angle B is equal to angle C. Why? Because angles standing on the same arc or chord I hate this topic because you had to write so much, right? Angles standing on the same arc or chord in the same segment are equal. Right. Is there anybody in class that does not understand this theorem? I want you to tell me no. Tell me one time. Guys, tell me.
Sir,
Are they confused at all?
yes, sir.
You
How
confused?
come it equal? How come the two angles equal?
All right. So these are a bunch of fixed theorems that just exist. I mean, they are long mathematical proofs, but these theorems, they just exist and its actual properties are circles, right? So here what I was saying, right? If you have an angle, okay, so somebody that was confused, let me ask that question, right? Number one, are these two angles in the same segment?
Yes, sir.
Yes, that's the first thing. Are they both standing up on the same arc or chord?
Yes.
All right. If you know that that is the case, automatically, all right, the angle at the circumference is going to be the same, right? Tell me if you understand that.
Yes, sir. Understand.
Okay, good. All right, let's move on to the other theorem. This one real straightforward. So, to the person I was just talking to, ma, I'd like you to give this a read for me. Give this a read.
Say repeated.
I'd like you to give this theorem a read.
A line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord at 90 degrees.
Right. So can we see that the line starts from the center and it touches the chord? Can we see that?
Yes, sir.
Guys,
Yes, sir.
will I be correct in saying that as a radius, or would that be wrong?
No, sir. That
That'd
is
be-
What would that be? I don't really know myself, right? It looking like piece of a radius, right? Piece of a radius. And what would this be? Faith, I
A
see you.
chord?
Faith, I see you on the camera, and like it's some bunny thing looking like Zootopia.
Trying to take it off. Sorry, I'm not join.
Oh, that's all right. That's all right. Guys, don't stress. Don't stress. I just see that pop up and I was like, what? I got kind of confused. Yeah. All right. So, guys, once you have a line from the center, right, and it goes down and it touches the chord, the angle it forms in the middle is 90 degrees. So, let me just go over that theorem, right? All right, guys. So, the angle formed over here would be what? What would it be?
90.
90 degrees.
So, again, the line must start from the center, right? And the point at which it touches the chord, it creates a right angle. So that's the other theorem you need to know. Let's look at the other theorem, right? So this one is, okay, you see the first one? Please commit it to memory. Just bring that nearly every year. You need to know that theorem. Please, right? Please. This is the other theorem they like to bring. So somebody else, I would like you all to give this a read for me. Get this theorem a read. Get that theorem a read for me.
the angle at the center of a circle is twice the angle at the circumference.
Right. And I have a really good way to show all this. Wait, I can answer. Right. I had the rubber band. I want to show a little something, right? Just remind my guys, which distance would be more? The distance for the radius, right? Or the distance for the diameter? Which one would be more?
The distance from the radius.
From the radius.
And the diameter.
Yeah, is the diameter. You can see what? This is the diameter. I draw this real bad. Right?
Better.
Watch that. Which distance looking longer? The distance from for the radius or the distance at the diameter? Which one do you find looking longer?
The diameter, sir.
Right. Now, guys, let me just take off the I'm gonna stop shit. The bunny. Right? Guys, let me just say I have a rubber band here, right? As it is right now, what is the angle here? What's this angle?
90 degrees.
180.
Yeah, this is 180 degrees, right? If I pull it a little bit, what happened to the angle? Did it increase or
Getting
like
smaller.
It decreasing.
So guys, if I pull it, what happened to the angle? What happened to the angle?
It got really
It
small.
gets smaller.
Yeah, guys, it gets smaller. So my question is, right? Which angle you think will be bigger? The one at the center, or the one at the circumference that got stretched? What do you all think will be bigger?
The one at the
The one at the center.
Exactly, the one at the center, right? And another thing. Hence, we know that the diameter is 2 times the radius.
Yeah.
Yeah, so the angle at the circumference would just be a half of the angle at the center. So you see, you can remember these things in a practical sense. It makes sense. The more you stretch a rubber band, the smaller the angle will get, right? So this rule basically says, if you have 2 angles standing on the same arc or chord, the angle at the center is 2 times the angle at the circumference. I will go over it again, don't worry. So I want somebody to just read this one more time. You need to remember this one. Please remember this one. Somebody read it back one more time.
The angle at the center of a circle is twice the angle at the circumference.
Right. And do you all understand the intuition, like the sense behind it?
Yes, sir.
Okay, good. So let me just run through that example. All right, let me just run through that example. I find it real quiet tonight, boy. I don't know what's going on. How are you quiet tonight, so boy? Don't worry, I bring enough energy for all 31 of you. Don't worry, I have it. So check this, guys. What is this? I just created an angle at the what?
Center.
At the center.
Right? Let's just call this A. Let's just call this B. Right? So I would say that this is arc AB. I confuse a little. Like if I say that this is arc AB, am I confusing anybody?
No, sir.
Yes.
And okay, if you're confused, right? Remember when we looked at the properties of a circle, I said if you had a sector, then piece at the circumference, right? Piece at the circumference, you call that the arc, right? If you cut piece out of the circumference, you call that arc. And if that confusing you, remember, circumference is just the
No, only remember the minor sector parts.
okay. You remember what the arc was?
I don't think I remember you saying that last night.
Okay, well, we looked at it today. Let me just explain something, right? Do you know what this blue line is called? Like the blue line around the circle? That's what C.
No.
C.
The circumference?
Right, the circumference. So what I'm saying is, if you cut a slice out of the circle, right? Cut a slice out of the circle. Wouldn't you cut a piece out of the circumference? Like what? If
Yes.
I take this slice and I remove it, right? And this length over here would just be piece of the circumference.
Yeah.
Yeah, so that is what we call the arc, right? The arc is the outer length for a sector. And you can think of a sector like a slice of pizza, right? So look at this again, right? Let me just show you this again. So can you see the slice the slice of the circle, like you cut a slice out of the circle, see that?
Yeah.
And you see how, like, imagine I cut this, right? Wouldn't this be piece out of the circumference?
Yes.
Yes.
You call that arc, right? So AB is an arc, Now the rule goes like this. If you have two angles standing on the same arc or chord, right? The one at the center is 2 times the angle at the circumference. So watch this, huh? Watch this. If I say that the angle at the circumference is 35 degrees, how much do you think the angle at the center would be? Take a guess.
70.
70.
70
70.
degrees?
70 degrees.
70.
Great, right? And the only way this rule would work is if the two angles standing on the same arc, right? So arc AB or chord AB. Let me show you an example where this wouldn't work at all, right? And a lot of students just fall for this. I don't know why, but I hope all they wouldn't fall for it. Check this out. I will run all it through all the instances where students would fumble the bag. Let me just say we had a question like this, right? Let me ask all of that. If we had a question like this, can you use that theorem?
No.
No, because it's not in the middle. It's not touching the
The center.
Yeah. It's not touching the center, so you can't use that theorem, right? You can't use the theorem over there. Another instance where students make mistakes, let me show you where students make mistakes too. They might do something like this. They might get a question, and the question might look like this, right? All right. For some reason, if the angle here is 70, they might say that this is 35. That's wrong. They can't do that. Could somebody tell me why that's wrong?
Because
Because the angle at the top.
Because they're not standing on the same chord.
Exactly.
The same arc.
So I feel like I confused some people. So in an attempt to rectify the confusion, I'll explain this, right? Now, for this theorem to work, both of the angles, right, they need to be standing on the same arc or chord. So this would be arc AB, right? As you can see, this angle, think of these two things as legs. You can see it's standing up on AB, right? And think of these two as legs as well. Guys, where that's standing up on? That's standing up on what?
AB.
AB, right? But let me just give these a couple of letters, right? Let's give this a couple of letters. Oh yeah, normal alphabet, watch. A, B, C. Ah boy, I could do English vibes now. Actually, no, I hate English. Right? Yeah. So question, guys. What arc is this angle standing up on? Imagine these two things are legs. What arc is it standing up on?
AB.
Okay. Imagine this angle has legs. What arc is it standing up on?
AD.
AD.
Are they standing up on the same arc?
no.
No. So I cannot use that theorem, right? Again, I'm showing all of this and I'm taking all the word out. I wouldn't make any mistakes like this in the exam, right? Though I'm showing all the what could go wrong. So don't make the mistake in the exam. So are we okay with the first 3 theorems? Let me know if we're okay with the first 3
Yes, sir.
theorems.
Yes, sir.
All right. If you're confused, now is the time to tell me, because when you see them questions, boy, oh boy, your mind gonna get fried. It is be a bunch of things. So you need to understand each of these theorems 100%, right? Okay, let me move on. This is another one of CXC's favorite. They love this too bad, right? Look more Baba in these in the TikToks that he don't understand. Stefan, when I come to get my next haircut, I go explain it to you, right? I go explain it to you. Okay, so I want somebody to read this for me now. Somebody read this. Read this.
The angle between the tangent and the side of the triangle is equal to the interior opposite angle.
Okay, That's a lot of big words. So let me try to break this thing apart. So guys, what shape is this?
Triangle.
Triangle. Notice something about the triangle. The triangle is touching all the points at the circumference. Can you all see that? Are you seeing what I'm talking about?
Yes, sir.
Yes,
Okay.
sir.
So for you to use this theorem, that must be the case, right? Number one, that must be the case. Number two, what is this? What would I call this? Remind me, what would I call that?
A tangent.
We have a tangent there, right? And what shape we have on the inside?
A triangle.
Okay. So my question is, right? If I have a line here and I have a triangle, wouldn't it create an angle over here? Are you seeing what I'm talking about?
Yes, sir.
Yes.
So this theorem works like this. The angle on the outside would be equal to the angle on the inside with the opposite one. So how I like to show my students, I'll just say, think about x, right? If this angle over here, well, it would just be equal. Just draw your x and you'll see which one it applies to. That's it. So to use this theorem, number one, you must have a triangle that touches that. Okay, so all of its vertices needs to touch the circumference, or, right? Or that's number one. Number two, you must have a tangent. If you don't have a tangent, you can't use this rule. So guys, anytime when you're doing a past paper question or you see a tangent, think about this rule, right? Think about this. Next thing, between the tangent and the side of the triangle, two angles are going to form. Two angles are going to form. So this angle over here will be equal to this angle. So you would say interior opposite. This angle over here would be equal to this angle. Again, interior opposite. Tell me if you're confused. Let me know if you're confused. Okay, I'm hearing a lot of silence, so let me actually try to do a question on it. Let us actually try to do a question on it, and we'll see if you will actually understand. Quick question, guys. Is this a tangent?
No, sir.
No.
No. No.
You're trying to trick me. Because they kind of touching inside the circle.
Is that imposter, right? Is that imposter? Is that imposter?
Yeah.
Right? Okay. So we have a tangent. All right. Okay, what shape did I just draw? What shape is that?
Triangle.
That
Triangle.
Triangle. Okay. Can you guys see that there's an angle between the triangle and the tangent? Or that confusing here? Some of that confusing here.
I can see it.
Yeah.
Well, you see what I'm talking about? Watch.
Yes, sir.
Yes.
So some people was confused about where's an angle. You can think of an angle as the space between two lines connected at a point. So like what? So like, you see how I have two fingers here and I connecting them at a point? The space between the two fingers is the angle, right? Angle is just a space between two connected lines. That's it. Right? So you see how we have this line and it connected over here. The space in the middle is an angle, in case it was confused. Right? So we have an angle over here. Are we seeing another angle? Tell me, are we seeing another angle?
Yes, sir.
Yeah.
Yes, sir.
Right. We seeing one over here. All right. So let's just say that what angle is looking like, guys. Give my answer. Give my angle. Give my angle. Give my angle.
50.
50. Okay, and let me see how good all is, right? I just want to see how if I'll learn some stuff from the past sessions, because we do trigonometry the other day, right? What if I told you that this was 89 degrees? Is it possible for me to figure out for the blue angle?
Yes.
Yeah.
Yeah, I want somebody to remind me. What is the sum of angles along a line?
180 degrees.
Right. So if I know that this is 89 and this is 50, how would I figure out the blue angle?
You're just adding together the 89 plus the 50 and you're taking it away from 180.
Yeah, that's correct. That's correct. 50 plus 89 right? That is 139, and that will be 41. Just confirm that, 41 degrees.
Yes, sir, 41.
Ah, boy, they got me. Math guys for you. I just surprise myself sometimes with our mental maths. At some times, like last live yesterday, I do some crazy mental maths time to time. We go if I fumble the bag, I'll go point it out, right? Because I'm not trusting myself 100% with the mental maths. If I make a mistake, just tell me one time. I don't want any mistakes to be in the notes, right? So this is 41 degrees. Okay. So I want somebody to tell me, what do you think this angle here would be? Let me see if I can figure it out.
50 degrees.
50.
All right. And what do you think this? I actually have two ways to find for that end. And we already know that this is 50 and 89. And we could just add it up and take it away from 180. Yeah?
Yes, sir.
Yeah.
Yeah. But if you use the theorem strictly, the angle between the tangent and the triangle would be equal to the interior opposite angle, so 41. And if you're still confused, just think about it like this. Guys, just draw X. Just draw X, right? I find like maths is reminding I X too much. Like maths the way to move on. And anything is be X and Y, right? But anyways, let me know if I understand that. I understand this 100%.
Yes, sir.
Yes, sir. Yes, sir.
All right, so let me show you some mistakes students make. And I'll show you all of this so they don't make the mistakes, right? Because when we start the questions, some of them might make some mistakes. That's okay, but pay attention and try not to make any mistakes. Let's just say we had this shape over here. Tell me, guys, can I use the theorem on this shape?
No.
Yes, sir.
No.
No, I can't do this. I can't do this, right? And the reason for that is because if you notice, that vertex of the triangle, it doesn't touch the circumference. Are you seeing that?
Yes, sir.
Okay, so I
Yes,
can't,
sir.
guys, you can't do that, right? Right? Yeah, that's like the main mistake students make, right? So let me give you all a question to see if you fully understand this. Let me do it in one color because CXC not gonna make color paper in color, right? Everything gonna be the same color, and it's gonna be hard to differentiate what you're seeing. So let me just make everything in the same color. I'm gonna make all the life a little easy, make it a little hard, right? Okay, we go work with that. I want to see how good Ole is, right? I believe in Ole, no, I believe in Ole. I want to see. So like, what guys 41 degrees, right? What if this is angle X, right? We just say that this is, let me use the same color. I don't want to give Ole any help, right? Let me just call that angle Y. Let me just call this angle Z. Actually, I'll leave this blank, okay, and I'll call this Y. All right, so let me see how much I actually learned. Now, with this diagram, you're only going to be able to figure out half the information. So try to figure out what Y is. Could anybody?
Y is 41.
Y is 41, right? And this angle would be what?
X.
It would be X. It would be X, right? Great. Great. Right. All right, so Y would be 41 degrees, right? And this missing angle over here would be whatever X is. Guys, did we understand this tricky example?
Yes, sir.
Yes.
Okay, I feel like some people are still confused and they're not saying. I'm running to one more. You confused?
Yes.
All right. Karina, does you?
Well, yes.
Okay, well, you know how to say it like that. I can't see who in the meeting, right? So I'll make a guess, right? I'm glad I know your voice. So which part confusing you?
Y is XX.
Y is X
Yeah,
X?
what the numbers?
Okay, I'll leave all the numbers to show you that it works. Like, okay, X, Y, and Z could be any number, right? The letters just represent, it's like a slot. That they could be any numbers. So what if I tell you X was, say, 50, right? X would be 50 and this would be 50, right? The letters just represent some number that we don't know, right? So you would apply the same rules, just put back the letter, right? Karina, let me run through back the theorem, right? So Karina, what is this? What would I call this? Remind me, what was that? Oh, what's that line, Karina?
I honestly don't know. I now join class.
All right, so that's a tangent. It's a tangent because it touches the circumference at one point. Do you know what the circumference is?
The middle.
No, the circumference is the distance all around the circle, right? So the distance around the circle, that's the circumference, right? And this is a tangent because it kind of grazes in the circle. It touches the circle at one point, right? Let me give you an example of another tangent. Look at that. Can you see that? Can you see that the line touches the circle at one point? Can you see that?
Yeah.
Yeah, so that's our tangent, right? Would you say that this is our tangent?
No.
No, because it's touching the circle at 2 points, right? So here what I'm saying, right? If you have a tangent, right, and you have a triangle inside the circle, the angle that is between the tangent and the triangle is equal to the angle on the inside of the triangle, but the opposite one. So those two angles will be equal. So you see how this was x degrees? This would also be x degrees. X could be any number, right? And you see how we have the angle here? That would be equal to this angle over here. Right? So if this is 41, this would have to be 41 as well. You understand that a little better?
Yeah, I understand.
All right, well, let's do a question then. Make sure you have that locked in. Okay. Okay, guys, I have two questions, right? Let me just call this angle X, right? And let me just call this angle Y. Actually, I'm gonna associate any degrees with it. I'll just call that X and I'll just call this Y. All right, so Karina, can we see that this is a tangent? And you can see that's a tangent?
Yeah.
All right, and then you can see that I have a triangle here?
Yeah.
Right, can you see that there's an angle between the tangent and the triangle?
39 degrees.
Right, so that would be equal to the angle on the inside that's opposite to it. So what is Y equal to?
39 degrees.
Right, that's it. Y is equal to 39 degrees. And somebody else, what do you think X would be?
61. 61.
Right, 61 degrees. Great.
So that's the whole question.
That's it. We're going through the theorems one by one. When you're doing the actual exam questions, they will slap on a bunch of theorems, right? But I'm covering the basics so that when we do any harder questions, you will know each individual theorem. You wouldn't be lost, right? Okay. So now is your chance. Did anybody not understand any of the 4 theorems we covered thus far? Let me know. If you understand, unmute and say yes.
Yes, sir.
Yes, sir.
Yeah.
Right.
Yes,
Or you could unmute and be like, vibes. Now we're talking about, you know,
Yes,
give me
sir.
some energy. Right? I finally real dead tonight. Who knows with the energy? Oh, right. So we understand 1 to 4. Great. CXC love to bring this one, and this is one of the easiest ones. Right? I want somebody to give this a read for me. Give that a read. Give
The
that
angle in semicircle is always 90 degrees.
right. The angle in a semicircle is always 90 degrees. Now I have a question for you guys. What would I call this?
Diameter.
Do you all agree?
Yes.
How about the rest of you guys in class?
Yes.
Yes, this is the diameter, right? Why? Well, it goes from one end of the circumference to the other end, and it passes through the center, right? So that's what diameter is, right? Guys, would this be a diameter?
No, sir.
No.
Somebody said yes. No, it wouldn't be a diameter, right? Why? Well, the diameter has to pass through the center. And if this is the center of the circle, and you can see it not passing through it. So if it's not passing through it, it's not a diameter, it's a chord. Right? Would this be a diameter?
Yes, sir.
Yes.
Right. And a diameter cuts a circle into what?
And half.
In half. And what do you call half of a circle?
Semicircle.
Exactly, right? Exactly. So once you have a diameter, I want you to be thinking about this theorem one time, right? So the angle, right? The angle in a semicircle is always 90 degrees. Angle at the circumference is always 90 degrees, right? Again, the angle in a semicircle is always 90 degrees. Lock that in your memory, right? So let's go through that. One of the easier ones to remember, right? So okay, how much of you guys in class say that this is 90?
I agree.
Sir.
I agree.
No, sir.
I had real people agreeing, boy.
No, sir. They're not correct, sir.
No.
No, sir.
No, not correct.
Why?
Why?
Well, look it right there. It's in a circle.
Is it
Why it's not
okay?
touching?
I want somebody that understands to explain to everybody in class why this is rubbish, why that's wrong.
Because the line is not at the center and not touching the 2 points of the circle.
Well, it's not supposed to draw it touching this.
But it's touching two points right there. It's
Yes,
touching 3 a matter of fact.
right, it is. But guys, is this a diameter? Is that a
No,
diameter?
it's not.
No, sir.
No, I
That's
want
a
somebody.
left angle.
So it needs to cut the circle in half.
Exactly. The theorem says the angle in a semicircle is 90 degrees, right? So the only way it will be a semicircle is if you have a diameter, right? And the diameter goes from one end to the other end and it passes through the center, right?
I'm still confused.
Okay. Watch this, right?
From a correct example.
In the center of the circle.
Wait, let me show you something, right? Watch this. Watch this. Can somebody tell me what this point is in the circle? What is that point in the circle? What's that?
Center.
Center.
That's the center,
It's
right?
not in the center.
We're gonna say that is in the center. That's in the center. All right. We call it that is the center of the circle. If I draw a line from one end to the other end, passing through the center of the circle, what do we call that? What is that? What is that blue line?
Diameter.
It's a semi.
And what does the diameter do?
Cut the circle
That's
in
the
half.
circle.
Right, diameter cuts the circle in half. Right? And we know that half of a circle is a semicircle. And the theorem literally says, right? It says the angle the angle in a semicircle is 90 degrees. So this is a correct example. I heard somebody said they wanted a correct example, right? This would be 90 degrees, right?
Okay, that makes no sense.
Right? There's another example. This is a 90 degrees angle. So can you see that the diameter cuts the circle into one semicircle and another semicircle?
So, but it's also a quadrilateral.
Well, how I drew that there,
So just to be clear, the line must go right down the middle, right?
exactly. It
That's
must
all.
go down the
Okay.
middle. Because if it's not going down the middle, do you think it's cutting the circle in half?
No.
What? No, watch. Let me give you a example, right? Does this line look like it's cutting the circle in half?
No.
No, sir.
No, right? And this rule only works if you're dealing with a
Semicircle.
right. Only works if you're dealing with a semicircle. Somebody mentioned quadrilateral. We're getting onto that just now, right? Cyclic quadrilaterals, right? But I was just giving earlier an example now. Watch. So if they drew another triangle here, what's the thing the angle here would that be? What do you think the angle would that be?
90 degrees.
90 degrees.
Yes, this would be 90 degrees. Now back to this example. Guys, is the diagram showing us where the center is?
No.
No,
No.
sir.
No.
Sir.
In maths, you can't assume, I tell you that from now, you can't assume. You cannot assume that this is passing through the center. Unless you're seeing the center, you can't assume. So guys, the moral of the story is, can we call this a diameter? Yes or no?
No,
No.
sir.
No. Because the diameter passes through the
Center.
center. And the diameter cuts the circle in
Half.
right. So just to finally wrap up any confusion, right? Guys, do we know where the center is for this circle? Do we know where the center is?
No, sir. Yes, sir.
No, we don't know where it is. They didn't provide it to us, right? Sometimes in the CXE exam, they might give you a diagram like this. They wouldn't show you where the center is. So you can't assume that this passing through the center, right? So let me just draw this line in red to show there's an imposter, right? This is not a diameter. Not a diameter, right? If you look at the diagram, can we see that the circles, like the different regions, like one smaller and one bigger? I'm gonna follow you could see that.
Yeah.
Which one bigger, one or two?
Two.
Two.
Two. So guys, did we create semicircles or no?
No.
No, we didn't create semicircles because semicircles is literally equal halves of a circle, right? So we cannot use the theorem here because the red line there is not a diameter. It needs to pass through the center. Needs to pass through the center, right? So I can't use the theorem over here. So a lot of students just make this mistake. Can't do that, right? To the persons that were very confused, do you understand why this is wrong? And I can't say that this is 90. To the people that was confused, do you all understand why we can't say this is 90?
Yes.
Okay. All right. Let me give you a second example, right? Second example. Okay. How much of you agree that this is 90? And how much of you, okay, so let me take a count, right? So agree and disagree.
Checks.
All right. How much of you all agree? Now think carefully, right? Remember, it has to pass through the center. Does anybody agree? All right, how much people disagree?
I
I
disagree.
disagree.
Me.
Right.
I disagree.
Me.
Why can't I use the theorem over here? Why can't I use the theorem?
Because that is not a diameter. It doesn't pass through the center.
Exactly. That is not diameter. That wouldn't cut the circle in half, right? What would I call this? What's the name of this? What's the proper name for that?
Chord.
A chord, right? So you can't use the theorem here, right? So if you was confused, I hope you understand now. If it's not passing through the center, then you can't use it. You can't use the theorem, right? Right?
So a question. So if they bring a similar graph design like this, right? And they tell you, okay, fine, look for 90-degree. Where we go from there?
If you are given a question, right, and the question looks like this.
So yeah, so
if the question looks like this, right? So look carefully at this diagram. Do you all think
no,
that this diagram?
this is like a 90-degree. You could get a 90-degree here. But
Yes.
what I'm saying, the first one, the one that you did just now, the example. So if they say give a reasoning, so therefore the reasoning would be the chord, the diameter of the chord is not 90-degree or something like that.
Some corrections. You would say that you would say AB is AB does not pass through the center, right? AB does not pass through the center. Therefore, it is not a diameter, right? It will cut the circle into a major segment and minor segment. Right, so this is what you would say, right? The easiest thing you could say is AB is a chord, not diameter. That's what you could say, right? AB is a chord, not diameter. But the main thing you need to understand, right? AB does not pass through the center. Therefore, it is not a diameter. And if it's not a diameter, it will not create semicircles. What it will create is a major segment and a minor segment. Understand?
Yes, sir. Thanks.
No problem. Question. Do you think, okay, this area over here, right? Let me just call this 1. And let me just call this 2. Which one do you think would be the minor segment?
1.
1.
1 would be the minor segment. And 2 would be the what?
Major segment.
The major.
Right, correct, right? So as you can see, that is not a semicircle, right? Because a semicircle is 2 equal halves, right? Yeah. So this is a correct application. You could use, this is an instance where you could use the theorem, right? So tell me, guys, do we understand this theorem 100%?
Yes, sir.
Yes, sir.
Yes. Yes.
Nice. We cooking, right? Okay, this one is rare, but you should still know it. This one hardly ever comes, but again, you should still know it, right? Somebody, read this for me. Let us all read.
Tangents from a common point A to a circle are always equal in length. So AB equals AC.
Right. Let's try to understand what is going on here. So, question: what would you call that? What would you call that?
Tangent.
Right. What would you call this?
Tangent.
And you notice that the tangents meeting at a point, and
Yes.
right. So the theorem says tangents, right, from a common point are always equal in length. So watch this. Do you understand that the tangent cuts the circle at one point? It touches the circle at exactly one point.
Yeah.
Right?
Yeah.
So it will, so for this particular tangent, right, it will touch the circle over here at B, right? And for this tangent, it will touch the circle at C. So in other words, AB, right, will be equal to AC, right? So once you have two tangents from a common point, the lengths it creates would be equal. Are you understand that?
Yes.
Yeah.
All right. And if you're confused, sorry, we will go it over. We'll go it over. All right. Let's do that quickly. Somebody give me a letter. Give me a letter. Give me a letter.
T.
T?
QP.
All right. We're going to use Q, right? We use Q. By the way, guys, what we just call that? A tangent or a secant?
A secant?
Yeah, secant, right? That's not a tangent. That is a tangent. That is a tangent. We Gucci now, right? We Gucci now. Nice. So let me ask you a question, right? How much tangents do we have in this diagram?
Two.
Two.
Right? Yeah, two, right? We have, I'm going to do it in different colors just to make sure absolutely nobody is confused. So we have one in blue and we have one in red. Guys, can we see that the tangent touches the circle at one point over there?
Yeah.
Okay.
Yeah.
And can we see that the red tangent touches the circle at that point?
Yeah.
Yes.
So what I'm saying is, if these conditions line up, right? Let me just say that this is, let me call this A, right? And let me call this B. Or let me make a guess. If this is the case, right, I can say that AQ is equal to what?
Isosceles angle.
I hear isosceles angle. No, it would be isosceles triangle. We'll get to that just now, right? So I would say that AQ, this length, is equal to which other length?
BQ.
BQ, right?
BQ.
Yes, BQ. Now watch this, guys. When they bring in this theorem, this is what they usually do. Somebody mentioned it. They would connect A to B, and in doing so, what kind of triangle that would create?
Isosceles.
Exactly. And if anybody is confused, an isosceles triangle has two equal lengths. And we know that AQ would also be equal to BQ. So guys, let me know if you're confused. Let me know if you're real confused. Tell me.
I just need a little re-explanation.
Okay, not a problem.
I kind of fall in the sleep zone a little bit. I wake up.
Right. So let me run it back, right? Let me run it back. Let me look at it from a different angle this time. Why not? So let me just put on a point here, right? Give me a letter.
PQ. P and A. PQ and R.
All right, PQ and R. All right, guys, this line that I just drew over here, what would I call that?
A tangent.
Tangent.
Yes, that's a tangent. That's a tangent. And oh yeah, right? Oh, I'm looking at this, right? And I attempted to draw a Christmas tree. But I'm gonna do that. Yeah, and the other line I just drew is our what? What's the other line I just drew?
Tangent.
Right.
Also.
So tangent.
Right. Let me know if you're with me so far.
Yes, sir.
Right? So, guys,
Yes.
you see, we have two tangents. We have two tangents starting from, where did they start from? What point?
Q.
P.
P.
Here, Q.
Point
I mean
P.
P. P, my bad.
Point is P.
Right? Two tangents starting from point P. And are they starting from the same point?
Yes, sir.
Yes.
Yeah, we see.
Yeah.
Look at this again for anybody that might be confused. So a tangent touches a circle one spot on the circumference. So watch. And again, the circumference is just the length around the circle, right? So we have a tangent here. It started from P, right? Then we have another tangent. See, it also starts from P. Nice. And a tangent touches a circle at one point. So guys, can we see where the tangents are cutting the circle?
Yes, sir.
Yes, sir.
Yeah, I'm seeing it over there, right? And I'm seeing it over here. Right? Do you all understand that?
Yes, sir.
Yes, sir.
Okay. Let's call this Q. Let's call this R. And let's just say that I connect Q to R. Let's just say I do that. Good note, so annoying. Bro, are they gonna see my like are they gonna see my crash out, you know, I fed up a good notes. I'm going to a shooting mode. I, I'm gonna find a meme that expresses my rage.
The with the fire.
Wait there. Right. Comment for good. For them, a comment for them. There. Good notes. The hunt is on. We're gonna hunt you down. We're gonna hunt you down.
Rally party, you know, no, no.
Yeah, boy. You know, when is the boss? The boss, you know. When is the boss? There's a jungle out there and the hunt is on. Let me shut up. I can't sing. This is one thing I can't do. I can't sing. I can't sing. Let me shut up.
You can sing.
Nah.
Man,
Don't give me false
yeah.
hope. Next thing, all you see me in Britain's Got Talent, and I start singing and them judge press X one time. Boy, don't give me false hopes.
Yeah, you still have our full support.
But I prefer Golden. Like,
Nah, you know, golden buzz. I can tell you that much. Maybe if I go as a comedian, maybe I might win. But like, no, I can't sing. Right? So yeah, right. Do we understand what's happening in the diagram so far? Let me know if you understand what's happening so far.
Yes, sir.
So again, we had two tangents, right? Starting from the same point, right? And the tangents would touch the circumference at one point. If we connect these points, what kind of triangle do we create?
Isosceles?
Yes, isosceles, because remind me, according to the theorem, PQ, right? PQ would be equal to what? Or would PQ be equal to?
PR.
PR. And if both of these lengths are equal, then we would have just created an isosceles triangle. So we would say that triangle PQR is an isosceles triangle. And guys, what do we know about the angles for isosceles triangle?
Two base angles are equal.
Right. Guys, and the base is like what the triangle is standing upon. I think you think of it like that.
Yeah.
So like if we have a triangle over here, right? Could somebody tell me what the base is? Like if I rest this on a counter, what's it?
QR.
QR, right? So for an isosceles triangle, you need to know this, eh? Trust me, you need to know this, right? The base angles, right? Base angles are equal. You need to know that. So, in other words, this angle, are you see why we call it base angles?
Yes, sir.
Okay, right? Because this is a base, right? And these are angles at the base. So base angles, right? So the base angles would have to be equal. They like to do that. They love to do that, eh? Right? So somebody tell me if this was let me just say that this was 49 degrees, how much this would be?
49.
49.
Yeah.
49.
That would be 49 degrees. They like to do that. And question, let me see how bad it is, right? If we know that that is 49 and that is 49, what would the blue angle here be? What would our blue angle be?
So not twice?
49.
Not 49.
And
Remind
is that isosceles?
82, sir.
Wait, guys. Wait. I'm hearing a lot of correct and wrong things. In an isosceles triangle, right? The base angles are equal. We already covered that, right? I told you that this was 49, so this would have had to be 49 as well, right? And these are the base angles. These are the base angles, right? So we already have the base angles equal, right?
So it's 49 divided by 2.
No, so 49 divided by 2. Let me ask that question.
249 plus 49 minus 180.
Yes, but I want to address the confusion. Somebody's confused, right? Question. To the person that's confused, if you add up all the angles in a triangle, what do you get?
180.
180.
180 degrees.
Right? Yeah. So if we know that this is 49 and this is 49, how would I find the missing angle?
You're going to add up 49 plus 49 and minus 180.
Yes. So that would be 180 minus 49 plus 49, right? 49 plus 49 is 98, and that should be 82.
Yes, sir.
180.
I'm wondering if that's correct with the 82. I'm wondering if the 82 is correct.
Correct.
Okay. So just to summarize, right? Just to summarize everything, I know we did a lot. This theorem says if you have two tangents, so if you have two tangents starting from the same point, in this case, they started from P, the points at which they cut the circle, right? It would work out such that the lengths would be the same. So in other words, PQ, right? PQ would be equal to PR. And if we have two equal lengths, what kind of triangle could we create? Anytime you have two equal lengths.
Isosceles.
Isosceles.
Isosceles. And what do we also know about the angles for isosceles triangle?
Two angles at the base are equal.
Yes. Right? Somebody just remind me, what is the name of these angles in red here? So the angles are the
Base angles.
right. These are the base angles. So base angles are equal. Right? Good. Good. And if we know that this is 49 and this is 49, they like to ask you to find for this angle. So just remind me, guys, if we look at triangle PQR, remind me, guys, what is the sum of all the angles in a triangle? If you add up everything in a triangle, what?
180 degrees.
180 degrees.
180. So 9 plus 40, take it away from 180, you get your answer, right? So we actually just looked at a possible past paper question. They could bring a question like this, right? So does everybody understand this theorem over here and how they could potentially bring it?
Yes, sir.
Yes.
Okay, good. Glad to hear that. Right? So watch this, right? Check this out. Let me just say that this question come, right? What would triangle ABCD? Remind me, guys, what would I call that triangle? What would ABC? Right? It would be.
Isosceles.
And what if I told you that this was 90? What did they give you that in the exam? How would I figure out for angle B and angle C?
Minus the 180 from the 90 and the 2.
Right. So I hearing some confusion. Let me clear up that confusion one time. So for the person that was a little confused, remind me, guys, in an isosceles triangle, the base angles are
equal.
Equal.
Now, and guys, I know it's looking a bit funky, right? It's looking a little bit weird. But if you were to rotate this triangle, where would it stand on? Like if you look at this triangle and you rotate, actually, let me just show you that. I'll show you what I'm talking about. I'll show you guys what I'm talking about. Suppose you have this triangle, right? Oh, shucks. Give me a second. I'm going to do like a very rough diagram. Yeah, so imagine you had a triangle there, right? If you take it and you rotate it, where would it stand on? Where would that stand?
Yes. It would stand on BC.
Do you all agree that it would stand on BC?
Yes.
Yeah, you are correct.
Yeah.
Yes, sir.
It would stand on BC. So guys, can we all agree that the angle at B and the angle at C would be the base angles?
Yes, sir.
Yes.
And the base angles in an isosceles triangle are
Equal.
equal. So when I take away the 90 from 180, right? When I do that, what am I going to get? What's 180 minus 90?
90.
So, and the sum of the other angles must give me the 90 to add to the 90 to give me 180.
Yes, sir.
Let me run that back one more time. So guys, do you all understand that the remaining angle would be 90?
Yeah.
Yeah.
And this angle, they have to be the same. So in other words, they are sharing that 90 equally. So what should I do with 90 to get B and C then?
Divide 90.
Divided by 2.
Exactly, and you will get 45 here and 45 here. Great. Good job, guys. Right? So they love to bring this one too, and this one is one of the easiest ones. Somebody read this one for me. Give this a read.
ABCD is a cyclic quadrilateral. All vertices lie on the circumference of the circle. Opposite angles add up to 180 degrees. AC equals 180 degrees. BD equals to 180 degrees.
Okay. I surprised you pronounced this word correctly, boy. I surprised I should get $1 for that, above you or something. How much all you think all you would have
Send that
pronounced?
virtual, sir.
Say that again?
You gotta send that virtually.
Wait, tell them to get the dollar. All right. Santa Claus come back. All right, so pronouncing the word correctly, my boy getting a digestive. Reduce sugar. You don't want to get diabetes. People eat healthy, right? I'm giving you $1. Yeah. However, guys, hear this. Wait. However, if you pronounce it wrong, I would give you a sense. That was a good one. I don't think I like it.
That was funny.
Yeah.
Yeah, because if you pronounce it I would have to give you a sense so that I pronounce it correctly. But anyways, right, big up yourself. And yeah, this is how digestive.
Not say bribing us during his class.
A bribing earlier? No, a rewarding earlier. Earlier.
Giving me $1 for being in your class, do you mean?
Okay, it have 33 people, and in the live it has 33 people. In the TikTok live, it's the same amount. That's crazy. I could afford to give away $1 each, right? I could actually afford it. I don't know how I'm gonna give away $80. I don't know what they're gonna buy with $1, but I could give away $1, right?
Sir, Bobby.
A bourbon too, Bobby. A pack of
Say,
cheers.
You can send it at Cash App.
Oh, I'm gonna send it in.
Cash App.
PayPal.
I guess I could do that.
No, sir, do it like them envelopes, sir. What Santa Claus just give?
You know what I'm gonna do? You know what I'm gonna do? I will take the digestive, break it up, and take. Oh, I real cheap man thing, boy. That real cheap man thing. I real cheap man thing. Okay, I wouldn't do that. Wouldn't do that at all. Okay, when I get real big,
And give it to the pigeon and let the pigeon fly with it, but then they actually end up eating it, so then we don't get no digestive.
wait, boy, that's crazy. That's a crazy plot, you know. Giving the digestive to a pigeon and the pigeon eat it. It's crazy. But yeah, don't worry. Like when I get like real big and like I have real money, like anytime I do these lives on I would like to meet up with my students. Like if it's Christmas, we could meet up and I could give all them something for like joining any lives and participating. I can't do that right now though.
I got 10,000, if you don't mind.
At 10,000, that might be stretching it. But if I was a billionaire, I wouldn't mind. If I was a billionaire,
Give everybody a Cassie.
yes.
You promised the Cassius.
Somebody who needs it.
I would give you all a Casio. Today I went in Gulf City to buy a bunch of Casios, right? For students in my class. Okay, I kind of people that do in my class right now, like my lessons, my Form 5 lessons, or like kind of get insight to give possible gifts. But I real search anymore, right? You know what them tell me? Them tell me it only has sharp. I look the man in the eye and say, you serious?
Casio is the best.
I just
It's
walk.
what happened to me today, and the shop have the audacity to be $200.
That's crazy. You know, you guess, here's something, right? The knockoff Casio, right? That has the same functions as the Casio.
The Sunway.
Sunway and the Quast 2 or something. I can't really pronounce it. The Quast 2.
Yeah, I was kind of hesitant to buy the Quatsu, but the guy was like, "This is the knockoff Casio," and it was only $105.
Telling you, the Sharp can't compete. The Sharp can't compete. I don't know what that's Sharp for.
They tried to charge me like $500 for Casio, and nah.
Wait. I have a perfect sticker for this. What? That's crazy. Right? But yeah, let me continue. So ABCD is a cyclic quadrilateral. Now we need to explain what a cyclic quadrilateral is. First of all you know is a quadrilateral. All you know is a quadrilateral.
Four sides.
Yes, sir.
No, sir.
Yes, sir.
Well, let me just explain to you guys that don't know. A quadrilateral. Guys, when you hear the word quarter, right? Or like quarters, what number you think of?
Four.
Four.
Three.
3? Bro, what? Whoa. I feel like rage bait, you know. I feel like rage bait. But 4, right? 4, right? And anytime you see the word quarter or something like that, 4, right? So when you see quadrilateral, that means 4 sides. Tag somebody that have 4 sides to them. You know, or some people will be like the two-face, like they have 2 sides. Some people, I feel like some people have 4 sides. I don't know what wrong with people, but like I feel like some people have 4 sides. But anyways, a quadrilateral is a shape with 4 sides. Simple as that. Or you can tell me a shape with 4 sides?
A square.
A square.
Rectangle.
Rectangle, quadrilateral, trapezium.
Right? A square. So let me go off. Let me pop off. Right? So a square. It's not really a square.
A rectangle.
No, a right angle is not a shape. Oh, wait, I think you mean
Rectangle.
I think this is what you mean. I think that way you mean. Like it is look like a right.
Sir, I think she said rectangle.
Oh, and I heard right angle. Sorry. Yeah. Right? Rectangle. So guys, question, is a parallelogram a quadrilateral?
Yes, sir.
Yes.
Yeah, okay. Is a kite a parallelogram?
Yes, sir.
Yes.
This is a sad kite. Probably wouldn't fly, right? But it's a kite. And yeah, these are rhombus. A rhombus is like a squished square. A parallelogram is like a squished rectangle. But all of these are quadrilaterals, right? Just keep that in mind.
Trapezium as well, sir.
Trapezium, yeah. Once it has 4 sides, it's a quadrilateral. So now we need to discuss what cyclic means. What do you think cyclic means?
It's not equal.
In a circle.
It means that it touches like, okay, each vertex, right? Each vertex
Touching a point of circumference.
right, touches the circumference. That is what quadrilateral is, and that's what cyclic is. Let me explain, right? So a vertex is this. These are vertices, right? These are vertices. Are you understand?
Yeah.
So what?
Yes, sir.
I'm going to draw a quadrilateral, and I want Ole to tell me if it's cyclic or not.
No, sir.
No.
This is not cyclic, right? Let's just call this vertex A, call this vertex B, call this vertex C, call this vertex D. Which one is the imposter?
D.
D.
D is the imposter. Right? D is the imposter, right? Right, D is the imposter. Okay, so guys, do you all understand that you can't use the theorem here? Because this is not a cyclic quadrilateral. All you understand that, right?
Yes.
Yes, sir.
Yeah.
So let me just make a note about it. This is not a cyclic quadrilateral. Right? Not. Okay. Let me do a question, a perfect example. Right? Okay, that will work, right? Guys, can we see that all of the vertices touches the circumference?
Yes.
Yes, sir.
Right? Okay, let me not do that. Right? So this one passes the test, this one passes the test, this one passes the test, and this one passes the test. Right? And we see it have 4 sides, so we Gucci. Now, if you have this situation, the opposite sides add up to 180, right? They are complementary. So let me show you what I mean, right? Let me just say that this was 91 degrees. What do you all think this would be?
89.
Yeah,
91.
that would be 89. And if you're wondering how I got that, I got that from one.
Oh, wait. 100 by. Okay.
Right? So I hope you're not too confused. Right? And what if I say that this is 79? Could somebody tell me what this angle would be?
101.
101 is correct. So guys, how much of you all are very confused? Are any of you all like real confused? Like if you're real confused, tell me.
It makes sense now.
I confused.
Okay,
I confused.
I'm happy that you tell them all you're confused, but I'm not happy, but like I'm happy that you're not staying quiet. That's good. Right? First things first, do you all understand what a cyclic quadrilateral is?
Yes, sir.
Okay. Now, what we are saying is that the opposite sides or the opposite angles in a cyclic quadrilateral add up to 180. Right? So, to the person that was confused, what is opposite 79 degrees? What's the angle opposite 79 degrees?
101. 101.
If you add 101 and 79, where you get?
180.
Right. So I'm saying that opposite angles must add up to 180. That's it. That's what.
Okay. No, I understand.
So watch this again, right? If I say that this is 91, where's the opposite angle? Where's the angle opposite to 91?
89.
89.
What is 91 plus 89? 91 plus 80.
180.
Right. So hopefully you understand that, right? So let me just put an explanation here. Right? Opposite angles in a cyclic quadrilateral right, add up to 180 degrees, right? And you would say that they are complementary. Let me just make sure that's the correct thing.
There's supplementary.
Let me just make sure. I just always mix it up. I'm being real as a math teacher, I'm being real with you. Supplementary, right? Check it to me fast. Supplementary.
Yes, sir.
Okay.
Supplementary.
Right? Supplementary. Supplementary means that the angles need to add up to 180. Right? Supplementary. Right? Supplementary. And supplementary just means that, right, angles add up to 180 degrees, right? So yeah, guys, make sure you understand this. They like to bring this. Yeah, they love to bring this. If you're still confused, tell me now. Tell me now. Is anybody still confused?
No, sir.
No.
Okay, let's look at an example then. Let's look at an example. So let's just say we had a cyclic quadrilateral. I'm telling you it's a cyclic quadrilateral, right? Not a trick question or anything. Let's just say this is a cyclic quadrilateral. Right? If I told you, okay, somebody tell me what our angle looking like. Give my angle. Give my angle, guys.
I would say 78 degrees.
Okay. All right. All right. Somebody give my angle for this. It's looking kind of big. It's looking kind of big.
93.
98.
I will say 101. Looking, because like this would be 90 with like, yeah, now looking like 100 or something, right? Okay, guys, let's call this A. We will call this B. We will call this C, and we will call that D, right? Somebody tell me, what is the angle opposite to C?
79
B.
B.
In a cyclic quadrilateral, the opposite angles have to add up to
180 degrees.
180, right? So guys, if this is 101, what would I have to do to find this angle?
Subtract it from
Subtract it.
Subtract it.
Subtract 101 from 180 degrees.
Right, and what would I get?
79.
79 degrees.
Right, 79 degrees. Good job, guys. Okay, and well, this is kind of obvious. What is the side, I mean, what is the angle opposite A? What's the angle opposite A?
B.
102.
Yes, 102 is the correct answer. Nice. How can somebody tell me how you'd find 102?
Because the angle is equal to 180 degree and we take away 78 from it. That's how we end up with 102.
Correct. Nice. Oh boy, dab them up, guys. My hand a bit sweaty. Let me wipe my hand. Okay, yeah, dab them up there. Big up on yourself, right?
Yes, sir.
Right, let me go. Wait, sir. All right, we cooking. Let me go. Right? So, anybody still confused? Tell me. Let me know if you're still confused. Are you guys still confused? We okay?
No.
All right. I'm gonna take it that everybody okay, right? Let's move on. So by now, right, we should know like most of the theorems. We have one more to look at. And this one real straightforward, right? Honestly, I would say none of these really hard. It's just when it's in when you have multiple theorems together, it's be kind of tricky. But it's not all hard. Like all of them kind of straightforward. Right? Okay. Let me look at the last one. So Nikolai, somebody else, he was reading the whole time. I want somebody else to read this for me. Give that a read for me.
The angle
between the tangent and its radius is always 90 degree.
Hearing a familiar voice, right? Hope I remember your name. Farzana. Not sure if that's saying that correctly. Because it sounds like somebody from Guyana that's talking. I only know one person from Guyana. Farzana, that's you?
Yes, sir.
Okay, big up yourself, right? Nice. So, Farzana, and do you know what's a radius?
Center to the circumference.
Right, from the center. This is the center, right? Going all the way to the circumference as a radius, right? And guys, and by now we know that this is a tangent.
Yes, sir.
Right.
Yes, sir.
Right. So the angle between the radius and the tangent is always 90 degrees, right? Always 90 degrees. So what we could do is we could actually look at that here. So let's do a quick example. So what did I just draw? Somebody tell me, what did I just draw?
A radius.
A radius. Okay. What did I just draw?
A secant.
Secant.
I'm waiting for everybody to tell me. What did I draw?
Secant.
A secant. Why? Why is this a secant and not a tangent?
Because it touches two points in the
Points in the circle and going outside.
I see, Bob. I see you say it's a chord, right? It's not a chord, right? A chord would simply join one point of the circumference, one end of the circumference to the other end, right? So that is a chord. But can you see that this line actually, it's outside the circle on either side, right? It extends beyond the circle. Anytime you have this scenario, you call this a secant, not a chord, right? This piece alone would be the chord. But if we're looking at the entire thing, that's extended outside of the circle as a secant. So guys, can we use the theorem over here?
Yes.
No.
No, sir.
No.
No, we can't use the theorem here because the theorem says the angle between the radius and the tangent is 90. That's secant. It's an imposter, right? Right. So guys, would I be able to use the theorem here?
Yes, sir.
Yes, I'll be able to use the theorem over here, and that would be 90. Guys, how are they feeling about this? Are they okay?
Yes, sir. Easy.
All right. Is there anybody that's confused?
No, sir.
Or let's tell me, if, or at least, if I understand, unmute and say vibes.
Vibes.
Bye.
Okay, nice. Nice. Okay, seems like we understand. So, guys, we just went through all the circle theorems you need to know, right? How are they feeling about the circle theorems?
No, man.
It kind of easy. No?
But you understand it, you'll get it. Hang of it.
I feel stable is just to memorize it.
Yeah.
Wait, but like guys, you see how we went through each one and we went through the concept? I think it's a bit easier to remember now. So here what we're gonna do now, right? I'm gonna troll it into the ocean, right? We're gonna run through some hypotheticals, right? Think of this as like mock tests, and then we're gonna move on to past paper questions as we plan for tonight. All right. So I given earlier some time. Look at all the theorems and soak it in like Berum. I don't know if you know about Berum. That's like a Trinidad thing.
Yeah, Beryl, didn't drink that.
What? Yo. Hey, wait here. Hey. Yeah. So, but like when I was small and we used to camp down Cedar side, I had this man that always drinking Berum in the farm. I don't know why. I really don't know why. Why are you doing that to yourself? I don't understand.
Beer, I'm cheaper than alcohol now, you know.
Yeah, cheap.
Boy, Ollie, drink water, it's free. I'm not talking about fire water, I'm talking about real water. Drink water.
You all know you're talking about
So who
fire.
say water?
Seawater even worse than alcohol because if you drink seawater, right? I'm gonna go on our biology rant here. So you know about osmosis sense?
Yes, sir.
So you willing to do a
Yes.
bio,
Yes.
I don't teach biology. I mean, I'm real good in science. I have distinctions in all my sciences.
So what's good in that teach?
I don't teach at school, right? I believe it or not, I do in my bachelor's in electrical and computer engineering right now. I'm a second year, right? I have been teaching since I was in lower six. So like 4 or 5 years now, right? The goal is to open up my own school eventually, but it's a process, right? And I feel like a lot of people still don't know about me, right? But eventually the whole world will know about Math Vibes. I'm manifesting that, right? But for now, things kind of, I still kind of as like a small fish in a big sea. But one day you'll get it. But what's saying about osmosis, right, is that if you drink seawater, right, because the salt levels in your body and like in your blood, is less than in the water, in your blood cells and in your body actually going to leave. So moisture going to leave your body and you're going to become very dehydrated. So if you drink salt water, it's going to pull the water from your body out and you could possibly die. Don't drink salt water, kids. Don't drink salt water. Well, obviously, if you're taking a little bit and thing, you're not
I
going to
thought you was gonna say the animal cells would burst. I
Well,
guess I need to study up.
no. That would be if it's really, really basic. That's a really basic solution. Regular salt water wouldn't kill you like that. Like it would have to be a more basic. The pH would need to be more basic. For that to happen, right? But yeah, don't drink salt water. That's what I'm trying to say. Okay, so guys, I'll give you another 2 minutes. Soak in what happened in here. Soak in all the theorems. And yeah, then we're gonna go it over and then we're gonna start past paper questions. Yeah.
You could just re-explain like two of them for me.
Okay, which two? Which two?
The weird looking triangles, those two.
I don't know what you're talking about. Let me just label it. Right? So 1, 2, 3, 4, 5, 6.
1 and 3.
1 and 3. Okay. Let me explain one again, right? I see somebody say 6, 7. These kids, yes. I see somebody say 6, 7 on the TikTok live. Karina, I know it is like itch here. Like it is like it's like every time I see it, you just feel like saying it. It's like an addiction and recovering from. All right. So I'm gonna explain the first theorem, right? Okay. So guys, can you guys remind me what I would call this black line over here? What would this black line be?
Chord.
This is our chord, right? That chord. Okay, so let's just call this C. Could somebody tell me where angle C is standing upon?
AV.
Right. So the person that was confused, right? I want you to think about like these two things as legs. Karina, if that is legs, right? What is it standing upon?
Wait, why isn't
if it has
CB the legs?
Okay,
The legs have to be it.
Okay, because this is the angle. This is the angle, right?
How you know that is the angle?
I know it's the angle, right? Because our angle. Okay, watch. If we say that this is our chord, right? If we say that this is our chord, can we agree that a chord is a line, not an angle? Can we all agree that a chord is a line and not an angle? Could we agree on that?
Yes.
No.
On the chord.
Okay, a chord is just a line, right? Watch. A chord is a line. By itself is not an angle, right? But watch this. Watch this. If I start from A and I go to the...
So you are informing us this is the chord?
No, this is a chord. Like it is like according to the properties of a circle, AB is a chord. It is a chord.
But isn't AC also a chord?
AC is also a chord. CB is also a chord. They are also chords. All of them are chords, right? But
There
here
are forces angles in a same segment standing on a same chord.
yes, I'm trying to explain that from scratch. So, Karina, what I'm telling you that this is the angle. This is the angle, right? The angle is always formed at the circumference, right? I've seen somebody write on the screen. Can you abstain from that, please? Right? So, Karina, I'm saying that the angle is at the circumference. And Karina, if this is the angle, what is it standing upon?
On the chord.
Which chord?
AB chord.
AB, right. Standing upon AB. Okay? Let's say we had another angle, right? Another angle. Right? So we have another angle there. Let's call that D. Karina, what is angle D standing up on?
On the AB chord.
Right. Are both of the angles standing on the same chord?
Yeah.
Are they, okay, do you know what segment is?
I heard it. I can't remember.
Okay, a segment is piece of a circle, right? So this is our chord, right? If this was our pizza, right? Well, your mother will beat you if you do this. But like, let me just say buy a pizza and I cut it like this, right? You just now make, and you just now have, like now you have two pieces of the pizza, right? Yeah.
Yeah.
So the pieces are referred to as segments. So this would be one segment. This would be the bigger segment. So we call this the major segment, right? And this would be the smaller segment. So we call that the minor segment. Understand?
Yeah.
So the segment is just piece of a circle, right? It's just a piece of the whole circle. So can we see that both of the angles in the same segment? Can we see that?
Yeah.
Okay, can we see that both of the angles standing up on the same chord?
Yeah.
If that is the case, then angle D would be equal to angle C. That's what the theorem says. So if
so they would have the same angle.
yes, they would have the exact same angle. So if I say that this is 49 degrees, what do you think angle D would be?
49 degrees.
Right. So the theorem says, let me just write it down here. So you'll have it locked into memory. Right? Angles, right? In the same segments. Angles in the same segment standing on the same arc or chord right, are equal. Yeah. So, Karina, do you understand it? Let me know if you understand this.
Yeah, I understand.
Okay, good. Let me just let me add more to this question. Right? Somebody besides Karina could also answer this, right? But Karina, I want you to try to explain it yourself. See if you could figure this out. All right, so Karina, let's just say that this is 100, not just say 99. Let me just say that this is 99 degrees, right, Karina? 99. What do you think this would be?
Also 99 degrees.
Correct. Correct. And let's try to justify that. Let's try to justify it. So guys, this is C, this is D. Could somebody tell me what angle D is standing up on?
AB.
B is standing on AB.
AB.
B, right? Could somebody tell me what angle C is standing up on?
AB.
AB.
All right. Are both of them standing on the same chord?
Yes.
Yes,
Yes.
sir.
Yeah.
Okay. Are they in the same segment?
Yes.
Yeah.
Yeah.
Yes.
So
So the theorem is angles in the same segment standing on the same arc or chord are equal. That's the theorem, right? And you hear me mention, this might probably confuse some people, right? Like I say arc or chord. Let me explain that. That has confused some people. Karina, and this is our chord, AB is our chord, right? AB is our chord. Yeah?
yeah.
Okay, what do you think this would be? What is piece of reference called? Arc. So let me ask you a question. What is angle D standing upon? If instead of using chord, we use arc, angle D is standing upon what?
On the AB arc.
Right. Angle C is standing upon the
AB arc.
right. So I hope that doesn't confuse anybody. When I say arc or chord, you can literally use it interchangeably, right? Guys, are we okay with theorem 1? Are we okay with it?
Yes, sir.
Okay. Karina, you okay with it?
Yes, sir.
Okay, good. All right. Let's go through the other theorem, right? So you said that theorem 3 was giving you trouble. All right. Okay. So, Karina, let's just say that this is A, this is B, right? So, Karina, tell me, that angle is at the what? What is at the what of the circle?
A
What do I call this?
ratio.
No, what do I call this point? What does it look like? It looks like the what of the
The
circle.
origin. The origin.
You can say origin.
Or
That's what C. That's what C.
The center, guys.
Yeah, like is the center, it's in the center, right? It's in the center. Center. So we have A, so angle A, so this angle over here, right? This angle over here, right? This angle is formed at the center. Okay? All right. And could somebody just tell me what arc this is standing upon? What arc is it standing upon?
AB.
yeah.
AB, right? Cool. All right, AB. Now, Karina, this other angle here now, this angle here, it is formed at the what? What is it formed at?
At the arc.
No, what do I call, like, okay, remind me, what do I call this? If it's a point along that, what do we call this? What is the outer perimeter of a circle called?
Circumference.
Right, Karina, the circumference. The outer part of the circle is the circumference. So, Karina, can you see that this angle is at the circumference?
Yeah.
Okay. So, Karina, the theorem goes like this. The angle at the center, like, okay, so once they're standing up on the same arc or chord, the angle at the center is 2 times the angle at the circumference, right? So, if this was 50 degrees, what do you think this could be?
Also
25.
50 degrees.
It would not be 50 degrees, it'd be 25. So, the theorem says that angle at the center is 2 times the angle at the circumference, standing on the same arc or chord.
So the one on the top would be like half of the one on the bottom.
Yeah, that's it.
Yeah.
Right, so you understand this?
Yeah, I understand now. Thanks.
No problem. So let me just write that theorem down, right? Right, so the angle at the center, right? The angle at the center is 2 times the angle at the circumference, right? Standing on what? Somebody tell me, standing on?
Chord.
Standing on.
Arcs.
Yeah, these are is a key word here, right? Yeah, this is same. Standing on the same arc or chord. Remember, guys, if it's not standing up on the same one, you can't use the rule. Look at this example, all right? Somebody, the angle here, what is it standing up on?
The arc.
AB, right? That's standing up on AB. Okay, what is this standing up on?
AD.
Okay, this is standing up on AD, right? So, guys, are they standing up on the same arc? Tell me, are they standing up on the same arc?
Yes, sir.
Yeah?
No, sir. No, sir.
Okay, so the person that said the same arc, I want you to unmute and we'll go over it together. I really need to clear up that confusion, right? So I want you to unmute, right? We're gonna go over this together, right? So to the person that was confused, tell me what arc is this standing up on? This angle here, what is it standing up on?
AB.
All right.
A and B.
What arc is this standing up on?
AD.
A and D.
Right, so this one is AD and this one is AB. Tell me something, guys. Is A to B and A to D the same? Are they the same? Do they look the same?
No, no, sir.
No.
No, no. So can everybody agree that those two angles standing on different arcs?
Yes, sir.
Yes, sir.
Okay, good. All right. And in this diagram, can we both agree that this angle and this angle, both of them standing up on the same arc, AB?
Yes, sir.
Okay, good, good. So Karina, is your confusion cleared up with 1 and 3?
Yes.
Okay, good, good. Glad to hear the confusion was cleared up. Right? So guys, is there anybody in class that would like me to go over a specific case? People on the TikTok that have any case or they want to go over in specific? Some.
No, sir.
Right, somebody say no. All right, Nikolai, that was you that say no?
Yes, sir.
All right, so are you ready for level pace now? Are you ready for questioning time?
Yes, sir.
Yes, sir.
Okay, cool, cool. Let me go.
Yes.
Let me go. All right. So if as soon as I see what I draw, right, I want to let it tell me which rule it could possibly use.
Recycling the quadra something.
Right, the cyclic quadrilateral.
Quadrilateral.
Right, so guys, if I said that this was 70 degrees, right? Okay, so let me just label it A, B, C, and D. Which angle would add with A to give me 180?
C. C.
So what would angle C be?
110.
110.
Ah, boy, good job. If I said B was 78, what angle added to B would give me 180?
102.
102.
Right, and that'll be angle D, yeah? Right? So 102. Nice, guys. It would seem that we understand. Seem like we actually understand this. Good, good. Okay, next question. Okay, what did I just draw?
Tangent.
Which theorem will I think I'm going to use if you see a tangent? Automatically, if you see...
90 degree radius.
Yeah, 90 degrees radius.
It's possible. That's possible, but CXC not a nice. What's the other one with the tangents?
The opposite angles, sir.
Yes. Well, the opposite interior angles. Yeah.
Yes, sir.
So guys, watch this, eh? Watch this. Remind me what has happened here.
So it's clockwise.
You get 2 angles.
Okay. So let me just call this A. I'll call this B. I'll call this C. So question, guys, if I said that angle, wait, I'm gonna look at how I'm gonna say this. Okay, let me call this T and I'll call this R. What if I said that angle BAT was equal to 79 degrees? Where would I put that? Would I put it by 1, 2, 3, or 4?
1.
Oh, they agree with that?
Yes.
Okay, good. Because remember, from the past sessions, I said anytime you see the 3-letter notation, they're talking about the angle in the middle. So they're talking about angle A here. Remember? Tell me if I remember. So
Yes, sir.
if you see
Yes.
and look at it like this, right? BAT, the angle in the middle, right? Angle A, right? Cool. So I'll put down a little 79 here, right? It's 79. And if I put on 79 degrees there, which other angle will be 79? Nikolai, somebody else. Somebody else.
C.
Okay, let me get some votes, right? How much all you say B? Anybody say B?
No.
Okay, so and again, nobody for B. That's good. Okay, what about this angle over here?
No.
Okay, no again. What about this angle?
Yes.
Yeah.
Yes, sir.
Right? And the way to remember it, like just draw X, bro, just draw X. Just draw X, right? Just draw X and you go see it. So this is 79 degrees. That's 79, right? What if again, I'm adding another trick here. I'm tossing another trick. If I said that this angle, what angle that looking like, guys? What angle that looking like? Tell me, what angle is that looking like?
Like 60 something, like 63.
It looked like 45 degrees.
It's 45 would be okay. If this is 90, 40. Actually, it looking like a little more than 45. So let me just say 50, right? So 50. If I told you all that was 50 degrees, right? And this is like an actual question that could come. What would angle B be? How would we find for angle B? There's two ways you can do it.
You would add up the 50 degrees plus the 79 and you're taking that away from 180 degrees.
All right, how much of you all agree with Faith? She said add up 79 and 59 and take it away from 180. You all agree?
Yes, sir.
Yes.
Okay, I agree with her. I completely agree with her, right? Because if you notice, we have a triangle here, and we have two of the angles, so we're missing one. So we just need to figure out the missing angle that would add up to give you 180. So that's one way you could do it. So 180, right? 180 minus 79 plus 50, that'll be 129. So that'll be 51. Let's verify that.
Yes, sir.
Yes.
So guys, if the yellow angle is 51 degrees, what other angle will be 51 degrees?
A
Tell,
as well.
wait,
Put on the other side.
tell me it using a three-letter notation. So
C-A-R.
yes. C-A-R, what? C-A-R. That angle. Right? So guys, let me know if we're okay with this.
Yes, sir.
And if you are correct, all of these angles here are supposed to add up to what?
180.
180 degrees.
Let's verify it. What's 50 plus 51? That's 101, right? And where's 79 plus 1?
180.
Right? 79 plus 1 is 80, so 180. Yeah, we are correct. We are correct. Good job. You know, I think I'll ready for a past paper question. I think I'll ready. How are you feeling? I think I'll ready. How the vibes feeling?
Yeah.
Yes, sir.
Yeah.
Okay, give me a year then. Give me a year.
Yeah.
2018.
2018, May or January?
January. May.
Okay, I hear me. All right. Okay, and guys, if we finish circles, well, I want to dedicate some time tonight to doing paper trees. So what I'm gonna do is, I kinda crazy. Maybe I might go till 12 tonight. So like, I would give a little break, right? And then we could come back and we could mash up the paper trees. I'm gonna do one paper tree with you. That should take 1 hour and 45 minutes, right? But I just want to do I want to do a good bit of circle questions, right? January 2018. No, you said June. Sorry, June 2018. Here it is. Okay.
So this class could be going on your YouTube later, sir?
Yeah, this is going on my YouTube.
Okay.
Yeah. Right? But I'll say this. if you're here and you're actively participating and you're actively learning, it's different from watching a video. That's the truth of it. Like it real difference. Because like when you're here, you can ask all the questions you want. You can tell me you're confused. I could clarify the confusion. So try to be here if you could. If you're real sleepy, you can leave and go and sleep. But if you want to be crazy and you want to mash up that maths, you gotta grind, right? Okay. So who wants to do this question with me? I want a volunteer. Who wants to do this question with me? Do I have any volunteers?
So you got along, man.
Volunteer.
So,
I hearing somebody volunteering themselves. Nikolai?
Yes,
Okay.
sir.
Well, I'll do the first question with Nikolai. Nikolai seems to know his stuff, right? So that'll be like a smooth process. And then I'll do a question with somebody that's not so confident. That's what I'll do, right? So Nikolai, we don't have to read all of this, right? Because they already have the information on the diagram already. Understand?
Yes, sir.
Right? So guys, like in the exam, please read it. But for the sake of time, they already have everything on the diagram, so we don't need to read this piece over here. Okay, so we are looking at this diagram. Let me just take a screenshot of this diagram so that when we do in each question, I could work with it separately. All right. All right. Copy. Yes. Okay, so Nikolai, they want me to find for A, B, C. What angle are they referring to when they say A, B, C?
Angle B, sir.
Angle B, right? So when they say, guys, so in the first question, they want us to figure out for A, B, C. Guys, what angle are they talking about?
B.
Angle B.
Angle.
One with the hat on top.
Right. So, but that might still confuse you because you might be wondering, are they talking about this? Are they talking about this? Or are they talking about this? That's the area where students get confused. So to explain that, look at this. Guys, didn't they say ABC? They said ABC, right?
Yes, sir.
So where would I start from if I wanted to draw that? Where would I start from? If it's ABC, where would I start from?
You have to start
A.
from A.
From B to
E.
C.
No, yeah, A. A, then to B, then to C. Right? And we're looking to see where the angle is. The angle will be in the middle of the two lines. Right? So let me do that. So A, I then go into B, right? And then I go into C. Can everybody in class see where the angle is?
Yes,
Yes, sir.
Yes, sir.
Right. So the angle is over here. That's how you know what to do. Now, immediately, guys, what is AB? AB is a what?
Diameter.
Semicircle.
Chord.
Nah,
Semicircle.
I hear chord. I hear chord. No. AB wouldn't be a chord, right? Could somebody explain why AB wouldn't be a chord?
Because it passes through the center.
Exactly. So to the person that said chord, AB is not a chord. It's actually a diameter because it goes from one end to the other end and it passes through the center. And remind me, guys, if I now realize people on the TikTok can't see it properly. Yeah. And if you have a diameter that cuts the circle in what?
Half.
Semicircle.
Right. So let me just make some notes to the side, right? So AB is a semicircle. No, what's it? Bro, AB is a diameter, right? And it would create two semicircles. Do we know any theorems with semicircles? Do we know any theorems?
Yes.
Okay.
Angles in a semicircle is 90 degrees.
So tell me what angle we could actually find for here, like immediately.
Angle C. Well, ACB.
Yes.
Right angle.
Are you confused by that?
No, sir.
So to anybody that might be confused, right? Okay, hear this, right? Yes. The question is asking us to find for ABC. That's this angle over here. But right now, we really can't do anything. Guys, to solve an equation in maths, how much unknowns you need to have?
2.
2, no, 1. 1.
One.
1. You can only solve if you have, okay, if you have one unknown, right, it's easy to solve. If you have two unknowns, you would need two equations and you would need to solve simultaneously. So what I'm trying to say is one is more than enough. I mean that in more ways than one. I give my life advice here, right? One is enough, right? So guys, based on the current situation, right? Just by looking at this, look at this triangle. How much things we don't know?
Well, for one, we know we already have the information. In the corner here is 58 degrees. Then we
Right.
have a 90-degree angle.
What if we didn't know
So
it
now
was,
we have two things.
oh wait, what if we didn't know it was 90? And the problem here is that we can't find for this because we have two unknowns. And you agree?
Yeah.
And like you just said, you said something great. You said, we know that this is 90. That's what you said. So guys, if we know that this is 90, and we can now find for this.
Yes, because all the degrees in a triangle add up to 180 degrees.
Correct. So we're going to say 180 minus, open bracket, 58 plus 90, close bracket, right? 58 plus 90, that will work out to be 32.
32.
32. Oh, they want to know how I do that so fast? Like in my head?
Because you're mad.
That's crazy. Karina, what is do you, boy? You real violent. I don't understand. But
Yeah, it's
Like to split up the numbers. It have a 5 and the 9,
yeah,
right? Because 5 is easier than the 4.
this is how I do it, right? For me to get 180, I would have to get 90 here. And so I could look at that and see 332, 32, 58, 90, 90 plus 90, 180. That's it. That's how I do that in my head. Right? Like, okay, I wouldn't, like if I doing this, I'm not going to add up this and say 148 and then take that away from 180. No, that's too much work. Right? I look in to see what number I would add to this to give a 90. That's what I'm doing. Right? But yes, I cannot mad as well. Okay, so do we understand the answer for the first question?
Yes, sir.
That was easy or hard?
Easy.
What do you think? That was easy or hard?
Right, easy, sir.
How about the rest of all you? Like I only hearing like Nikolai and a couple others. If all they understand, they say vibes. Like let me know. I need to know all they understand.
Vibes.
Okay.
Vibes.
All right. Good. So let's write down like look at what they say, right? They said giving a reason for your answer, right? So we're going to write in brackets the theorem we use here. Could somebody tell me the theorem we use? What was the theorem we use here? Somebody asked in the live if I have a YouTube channel. Yes, the YouTube channel is Math Vibes. Just click on my profile and you will see the link to my YouTube channel. I have real stuff over there. And when I finish with this, I'm gonna post this on my YouTube channel. Right? Yeah. So what was the theorem I used for this?
That is the
Angles in a
unit
semicircle,
diameter
90.
always 90 degrees.
Right. So angle formed in a semicircle is 90 degrees, right? So that's one thing, right? And well, the other thing we used was that the sum of angles in a triangle is
180 degrees.
right. Okay, is there anybody in class that real confused by this particular question? Tell me. Okay, guys.
Sir, one thing. Do you have to put like the angles in a triangle is 180? Like after you're done, right? The angles in a semicircle is 90.
Yeah, I would advise doing that because let me ask you a question, right? When you was doing this question, and to use that theorem over here,
Yes.
you put on that one, and to find for this angle, what we use? What fact did we use? we use the fact that the sum of angles in a triangle is 180. So I would advise you to put it down, right? I would advise you to put it down. Basically, when they ask you to say, give a reason for your answer, you want to say everything you did, right? Understand?
Sir, but only going for 2 marks.
Here, what in the exam, you could write that real fast, right? You could write that real fast. I'm not going to take that long. I'm not going to take that long.
Sir, I think they can give you a mark for your 32 and then a mark for your angles forming a semicircle.
Yeah, but I would like to be a little safe and extra, right? I would still advise you to put this down. It's showing them, like, okay, in a calculation, it's kind of implied that you know that, but it wouldn't hurt to write this, right? Because you're explaining, you're basically telling them why you did this, right? But
so therefore, so if I have to write something like this, right? I would have put like angles A, B, and C is equal to 180. Is that okay or no?
no. If you say, let me explain something, right? If you write A, B, C, right, that notation is talking about angle B. That's not talking about all the angles. Yeah.
Okay, noted.
So you had to say the sum of angles in a triangle is 180, right? If you're in a time crunch, just write this. You should get full marks, right? I mean, this was implied in a calculation here, but I would still write it, right? But the main thing here is that you're using this, like you said that, right? Okay, guys, we okay? Let me know if we okay with this question.
Yes, sir.
Yes, sir.
And my advice is, if you're fine for something, put it in your diagram. So we just found out this was 90. I'm going to put it there, right? We found out this was what? Remind me, what do we find that to be?
32.
32.
Okay, great. Great. Let's move on, right? I'm going to take the same diagram. Take the same diagram on YouTube. Use it. All right, so CMB. If it's CMB, right, what are you talking about?
Angle M.
Right, well, let me be a little specific, right? I'll be a little specific. Because I know for a fact, right, when all you see CMB and all you look at this diagram, all you hear go and fall off all your head. Are they going to be...
The first place my eyes went was the N.
So it looking,
I would have immediately say that it's 90 degrees.
And that would be wrong. I would be wrong. That would be wrong. Right? Here what is my advice. You see CMB, right? This is what I would tell you to do. If it's CMB, right, and I wanted to draw this angle completely, where would we start from?
A.
C.
It starts from C because it's CMB.
Sorry.
Right? You start from C, then you go to M, then you go to B, and you're looking for what's in the middle of the two lines, right? So start from C, right? Then you go to M, then you go to B, and you're looking for the angle in the middle, angle in middle. So this is what we're gonna do, right? So guys, I'm gonna put on my stylus by C, right? And from C, where am I gonna go to next? Where would I go to?
M.
Where would I go to next?
B.
Can we see where the angle is?
Yes, sir.
It would be the M.
Can we all see that?
Yes.
Okay, because somebody said they would up a 90, but no, like when you draw it like this, you're getting to see exactly what angle they are talking about. So CMB, angle here, right? That's the angle they're talking about. So this is what we want to find in the second part. Who want? Okay, Nikolai, help me one time, right? So Nikolai,
Yes,
I want you to look at the bigger picture. That's my hint. What kind of shape we have inside the triangle? I mean, what kind of shape we have inside the circle?
we have a cyclic quadrilateral.
Drop out one if you saw that. Drop out one if you saw the cyclic quadrilateral. Or like unmute and say vibes. Something like that. Did you all see the cyclic quadrilateral?
Vibes.
Yes, sir.
Right, so guys, do we know how the cyclic quadrilateral rulers work? Do we know how that does work?
Yes, sir.
Okay, we do know how it works. If this is 58, what do you think this could be?
It would be 100.
122.
Okay, I hear somebody say 122. Nicola, you agree?
Yes, sir.
Right, because, or somebody remind me, opposite angles in a, finish my sentence.
Cyclic quadrilateral
Cyclic
also
Cyclic quadrilateral.
Supplementary, sir?
Yes.
No, they add up to one.
No, if she say,
add up to 180.
guys, if all they say supplementary, you get your marks. Because supplementary means add up to 180, right? So the rule is opposite angles in a cyclic quadrilateral add up to 180. If you're being real simple, say it like that. If you want to be mathematical, say opposite angles in a cyclic quadrilateral are supplementary, right? So this would just be 180 minus 58, right? And that's going to be 122. You said 122, right?
Yeah.
Okay. All right. So 122. Is there anybody that's confused by this? Like, I understand that when you look at this question, you're probably not going to see the cyclic quadrilateral. I understand that, right? Be honest with me. How much of you guys would have had a hard time seeing the cyclic quadrilateral?
To be honest, if I didn't memorize the circle theorems, I wouldn't have seen it.
What about the
Sir,
rest?
and if you didn't point it out, I wouldn't have seen
You would not see it because you had this line here and I cannot cut in it. Yeah.
Yes, sir.
I noticed it's on Nikolai instead it's a cyclic.
So you see, you could know all the theorems in the world, right? But if your deductive skill is not good and you can't see it, pressure day, you're gonna be cooked, right? So you had to be real careful, right? Before you start the question, look at the diagram and you think of what possible theorems you could use, right? All you understand part 2?
Yes, sir.
Yes, sir.
Okay, so what am I gonna write? So I'm gonna write 122, of course. And in brackets, I'm gonna put opposites.
Opposite
Angles in a cyclic
That means-
quadrilateral add up to 180 degrees.
Right. Opposite angles in
supplementary.
cyclic add up to 100. Right? Or you could say supplementary. Right? Great. So guys, we okay with this question?
Yes, sir.
Yes, sir.
Good. Glad to hear that. Let's move on to NCM. Let me just borrow this diagram. And in the main diagram, I'm going to label the information we just found, right? So we just found that this angle was what? Remind me?
122 degrees.
22.
So guys, anytime you do a question, put down your information, right? Most likely they will ask you to use the same thing like a previous answer in the next question. Most likely. More than likely, right? You'll have to use what you found previously to do the question. So, okay. I just draw it. 122. All right. So NCM, right? Where, if I want to draw that angle and to see where it is, where do you all think I would start from?
The N
Let's
first.
start from N.
The N.
Then I would go to
C.
Then I would go
M.
M.
right. So let's see how that would play out. So I'm starting at N. Where are I going to next?
C.
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 Where are I going to next?
M.
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 M. So we want to find this angle over here. Are you understand?
Yes, sir.
Okay, good, good. Let me just highlight that so you can see exactly what I'm talking about. N, 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 C, M. Right? And we want to find, and these are different colors, so as to not confuse anybody. Who's green? Right. Now, when you look at this question, right, what triangle they kind of zoning in on? What kind of triangle we zoning in on?
Right angle.
Right angle.
So until you see that we looking at that triangle, can you all see right now in that triangle, how much angles we missing?
2.
We're missing 2, right? We missing this angle, and what angle we missing?
The right angle.
No, we know.
No, we have the right angle.
Sir, M?
M, yeah. To the person that said we're missing the right angle. Question. You see, anytime you see this square symbol over here, it means there's 90 degrees. Right? So we have the 90. Understand?
Yes.
Right. So we have the 90. We are missing this, and we are missing this. Now, guys, in maths, if you want to solve for something, how much unknowns you want?
1.
You want 1 unknown. Right now we have 2 unknowns. That's a problem. Before we could find for this angle, is there any other angles? Well, we only have one other angle.
Can you show us the full screen again?
Sure.
Please.
They want me to find for NCM. So that's this angle over here.
At first, I was going to say take away 122 from 180, but I guess that's not really making sense because we know that it's 90 degrees.
Wait. Actually, that would make plenty sense. That would make real sense. So much sense, I would give you $1. I would give you $1, right? So let me explain why you need to do that. Faith, right now, how much things we don't know? Look at that triangle. How much things we don't know? How much?
2 things.
Right? We don't know 2 things. However, what do we know angles in a line add up to?
180 degrees.
So if that is the case, is it possible for me to figure out for this purple angle here?
Yeah.
Somebody tell me, how would I find for the purple angle?
You minus the 180 from the 122.
Right? So I'll say 180 minus 122. Right? 58.
58.
Now, I want somebody to tell me, why was it important for me to find for the angle? Why was it important for me to find the angle?
So you'll be able to find C because you would need only, well, you can't have 2 problems, you have 1.
Exactly. Fellas, that's why you should only have 1 girlfriend, not 2. Right? Not the problem part, eh? I see my girlfriend going to kill my boy. She's probably watching this live. She go ask me if she's a problem. And I'll get licks. I'll watch what I say, Guys, I gotta watch what I say.
I wish you good luck, sir.
Hey, boy, how did you do it after class?
Blink twice if you need help.
Yeah, her glasses on, so you can't see. I really thinking.
Listen, and we don't judge.
It's a joke, it's a joke. Or is it? Anyways. All right, so guys, I don't get licks, I'm just joking. Right? Next thing people tell my girlfriend she beats a man. Anyways. Guys, if we look at this triangle now, right? We know that this is 58. We know that this is 90. Is it possible for me to figure out angle C?
Yes, so
Yeah,
could add 58 and could add 90 and then minus it by 180, sir.
Yes. So it will
But
be
why?
Somebody said, but why? I'll explain it to you. Give me a second.
Yeah.
58 plus 90. And that should be
And I find that thing too small to be 90.
It's 2 degrees.
You said it too small to be 90. That confusing me. Okay, 90 just means that 2 things are perpendicular to each other. Watch. If I wanted, I could literally do this. I could literally draw that, and I could tell you that is 90. I could literally do that. I could
No, so actually remember the other rule from earlier where you said when you draw the triangle, right? You're seeing the 32 up so, right? And you go clockwise the other direction. That rule I find would make more sense.
clockwise, you're talking about bearings.
Yeah,
This is not bearing, this is circle theorem.
I know, but
No,
and I
different.
shouted this explain it properly. I think it was earlier tonight you're showing us.
No.
I think she's talking about the
No,
interior
she's
opposite
talking about,
from.
yeah, opposite.
Oh, okay. All right. Let me explain why that might be troublesome, right? So we have a tangent here. Yeah, we have a tangent there. Right? Actually, wait, let me look at it fully. If we look at this triangle, so we have a no, it's a give me a second. So we have a triangle here, we have a tangent here. Now, according to what you're saying, right? You're saying that we have a tangent and we have two angles on either side, yeah? Okay, so this angle would be equal to this angle. Well, how are we gonna find for this angle?
Oh, okay.
Understand? You see, let me explain something, right? If we knew what, remember, this is a cyclic quadrilateral, right? If you knew what this angle was, you could have figured out what this was. Why am I saying that? Well, to the person that was confused, if I say that this is 101, what is whole angle going to be?
79 degrees.
Right, 79 degrees. And if the whole thing is 79 and this piece is 32, and I can then take away 32 from 79 to get this missing angle.
Yes.
And then I would be able to figure out for this, right? But that's real work, and we don't have enough information. Understand?
Yeah.
Yeah. So I hope that clear up any confusion you had. Right? So let me explain what we did here. Let me explain. They want us to figure out for this angle, right? This angle, angle C. So if that's the case, we are dealing with this triangle. So we know that is 90, right? How much angles we missing? To the person that was confused and they said I didn't make this, why? It was like real confused and they didn't think this makes sense. Tell me, how much angles we missing?
2.
You're missing 2, right?
2.
Now you can't do anything if you're missing 2 angles. You can't do anything. So what you need to ask yourself is, okay, is there a way to find for one of the missing angles? Right? Is there a way? Watch this. Somebody, what would I call that? Starts with L. No, I'm not tricking all you or anything. It starts with L. Is that what? L. L-I.
Line.
It's a line, right? And so you can see that this is a line. We could see that as a line, right? That's a line.
Yes, sir.
What are the sum of angles along a line?
180.
180.
So my question is, wouldn't this be 180?
Yes, sir.
Yes. If this is 122, how are we going to figure out for the missing piece?
By taking away 122 by 180.
Yes. And in doing that, we would now know 2 out of the 2 of the angles. And if you know 2 of the angles, can you find for the last missing one?
Yes, sir.
Yes. Because if you add up all the angles in a triangle, what are you supposed to get?
180.
Right. So guys, quick recap. At the start, in the problem, we have 2 unknowns. That's our problem. We need to figure out for one of the angles. If you look, this is a line. The angles along a line is 180 degrees. We know that this is 122, so we just had to take it away from 180 to figure out the missing piece, which is 58. Because if you add 58 and 122, what will you get back? What will you get back? Somebody tell me. What is 122 plus 58?
180.
Right, and that would make sense because this is a line and the angles along a line is 180. Nice. So if we know that this is 58 degrees and this is 90 degrees, and we also know that all the angles in a triangle is 180, all we have to do is just add up this, right, which is 58 plus 90, right? And then we're going to take that away from 180 to figure out the missing piece. Let me know if you understand how I get 32 degrees.
Yes, sir.
Yes. Vybe.
Okay, good. I like that response. I like the vibes, right? People on the TikTok, are they understand how I figured out that this was 32? Let me know. Kelvin Francis on the live. You understand how I got 32? Okay, great. Great. Somebody asked me to repeat the steps again. I'm going to do a quick overview, right? Quick overview. Faith, you there? Faith, let me know if you're there. Can I hear any Faith, right? I'm going to go it over quickly, right? They wanted me to figure out for this angle. If we're looking at the triangle, we have two unknowns. I don't know what this angle is, nor do I know what this angle is. That's our problem, right? We know that this is 90, but we're missing two angles. I cannot do anything if I have two unknowns. So what I need to do is I need to figure out for one of the other angles. If you look carefully here, this is a line. The sum of angles along a line is 180 degrees. So if this is 122 out of the 180, then the other piece would have to be 58 degrees, right? So in doing that, we found for one of the angles for the triangle. If we know that this is 58 and this is 90, we could add it up and take it away from 180 because in a far triangle, if you add up all the angles, it's supposed to be 180, right? And guys, if you're having some trust issues, and we can add up 32, 58, and 90. And we can do that?
Yes, sir.
Right.
Yes, sir.
What is 32 plus 58?
90.
What is 90 plus 90?
180, sir.
Right. So everything making sense. Everything making proper sense. Right? So our answer is 32 degrees. Right? 32 degrees. And Nikolai, what would he or what was the reasoning I used?
I would have put the sum of angles in a triangle is 180 degrees.
Right? Sum of angles in a triangle is 180 degrees. And what else did we use? How did we find for angle M?
The line, the sum of the line is 180 degrees.
Right? Sum of angles along a line is 180 degrees. So, people in the Zoom, how we feeling? We feeling good about our question?
Yes, sir. Plenty vibes, sir.
Yes.
Plenty vibes. I like that. We feeling like
So what paper is this?
this is June. Right now, this is how we feeling.
2018. Okay.
We chilling. Right? Cool. Let's move on. Okay, that's it. Be honest, guys. Is it something you feel like you just can't figure out? Or is it something you feel like you could understand if you keep doing practice?
You can understand it if you do keep doing practice, sir.
What about the rest of you guys in the Zoom meeting? What do you think about this? Do you think it's like
Yes, sir. I feeling confident if I do more of it, sir, I could mash them up.
well, here what? Let me do another question. To the person that said, here what, if I do another one, I could mash it up. You tell me a year. You give me a year. All right, give me a year.
2021
May or June? What's in? May or January?
January.
January? Sure. I think 2021 was COVID, you know. I think it's about 2021 people.
All right, 2022 then. So I think they'll do multiple choice for 2021.
Yeah. All right. Let me just erase the answer I have here. All right, so you're ready to mash up this question? You ready? Let me know if you're ready.
Yes, already.
Okay, good. Good. So, again, we don't have to read all of this because the information is already given to us on the diagram, right? All the information you will need is already in the diagram. All right, let's move on now. So, determine the value of each of the following angles, show detailed working where possible, and you have to give a reason for your answer. So we need to figure out for angle X, right? This looking a little confusing, but I would implore you to look at X, right? So are you thinking of any possible way to find for X? I know it's looking a little complicated, but trust me, not bad. Not bad. To the person that wants to do the question with man, I hearing you. Talk to me.
My brain hurting. I'm trying to figure out what step I should take.
Excuse me.
Yeah.
So on the side with the angle where X lies, right? I can see that it is in a semicircle.
Mm-hmm.
Sir,
Yeah,
I see the 90 degrees.
I see 90 degrees too, right? The person that wanted help, DB. I don't know your name. What's your name? What is your name?
Danielle, sir.
Say that again.
Danielle.
Danelle?
Yeah.
Danelle, you in the WhatsApp group chat?
Yes, sir.
Okay, vibes. Say no more. Say no more. Right, so you're inside then. You're inside. Nice. So, Danelle, what is
Yes.
what is OP? That's a what? It starts from the center and it goes to the
Radius, sir.
okay. What would I call a BA? What is BA? What is BA?
A tangent.
Yeah, BA is a tangent. You see that?
Yes, sir.
Right? So Danelle, if it's a line that grazing the circle, touching the circle at one point, right, is a tangent. Let me ask you a question. What is the angle between a radius and a tangent?
I forget, sir.
The radii.
Wait, guys. Before all you say all you forget something, what are you looking like? What angle is looking like?
A 90-degree angle, sir.
Yeah, I'm looking like a 90 degrees angle. So then now, try remember that theorem, right? So let me just take this diagram here, take it fast. Okay. Right. So I think everybody could see that we have a radius over here, right? Our radius. And we have a tangent over here. Right? So this is our radius. That's our radius, and this is our tangent. Right? And then now, what's the angle between our radius and our tangent? Remind me?
90 degrees, sir.
Right. Well, I'm gonna ask you a question, right? If we know that this angle is 90, right? We know that. We know that is 90. You with me?
Yes, sir.
Okay. We have a piece of the angle and we have another piece over here, right? This is 2x and this is 3x. So let me ask you a question then. If I add up 2x and 3x, what is it supposed to be equal to?
5x.
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 But okay, 5x, and that would be equal to what?
90.
So now, do you understand
90.
it would be 90?
Yes, sir. I'm sorry, it could be 90, sir.
Because then now check this. This is 90, right? But like we also know that this piece plus this piece, that would also be 90. I think they could see that, right?
Yes, sir.
We're going to say 5x, right? And 5x would be, 5x would be equal to 90 degrees. And now we want to find for 5x or we want to find for 1x?
1x, sir.
Right. If you have 5 or something and you want to find for 1, you'd have to divide both sides by what? Let me see, it's in a way that will make sense, right? The x is being multiplied by 5, yeah? And you see,
Yes, sir.
what's the opposite
Yeah.
by 5?
Divide.
Divide, sir.
Right. So if I divide both sides by 5, we're going to have one of these two 5s.
They will cancel.
They will cancel each other, sir.
Right. And it would leave you with 90 over 5. And 90 over 5 was 90 over 5.
18.
18.
Right. So then now, Selma, can you see it now? Is it clear?
Yes, sir.
All right. So beat yourself up. You're learning. Like you're here, right? You're here. You're giving it effort, right? You'll get it, right? It'll be fine, right? So x is equal to 18 degrees, and the reason is because, tell me now, the angle between
the radius is 90 degrees, sir.
I'll be a little more specific. The angle between what two? Wait, guys, give Danelle a chance to answer this. She's the one having trouble with this. So Danelle, the angle needs to form between what two things? Look at this. What two things?
The tangent, sir.
Tangent.
And the radius.
Yes. Right. So I would say the angle between the radius and tangent is 90. That's what I would say.
Okay, sir.
Feeling okay with that?
Yes, sir. Thanks.
No problem. Right. Let me move on. So let we fill in some information while we're at it now. So Danelle, we know that x is what? We know x is
18 degrees.
So anywhere I see x in the diagram, I can replace it with
18 degrees, sir.
Yeah, 18 degrees. That's straightforward, right? So you see this x over here, that's gonna be 18 degrees. How much do you think 2x could be?
36.
Again, guys, give Danelle a chance, right? So Danelle,
32, sir.
not 32, right? 2 by x. So 2 by 18. That'll be 36. 2 by 18, 36.
Okay.
Right? And over here, you're going to do 3 by 18. What's 3 by 18? 3 by 18. What's 3 by 18?
54.
Yes. You want to see something cool?
Yes, sir.
All right. What we did say this angle was, like the angle between the what did we say the angle between the radius and the tangent was?
90 degrees.
Okay, so I want you to add 36 and 54. Where's 36 plus 54?
$90 degrees, sir.
And what did we say the angle between the radius and the tangent was?
90 degrees.
See how everything work out?
Yeah.
Yeah. Right? So the Matson. Nice.
Yeah, it's Matson.
Matson. Right. Okay, great. Now we want to figure out what angle y is. Let me do that, shall we? Angle y. Copy this. All right. So here what, right? I'm just going to put back the previous information. Because with these types of questions, what you find in the previous part will come back to bite you. So this is 18. Right, give me a second, this makes it a little bigger. Right, so this is 18. This was what? Just remind me, now. This was 18, this was what? I don't know.
36. Sorry, 36.
And this one was 54 degrees. Cool. Now they want me to figure out for angle Y, right? So we want to figure out for this angle over here. We got to figure out for Y. Okay. So what triangle do you think we should be looking at? What triangle do you think we should be focused on right now?
X.
Wait, let Danelle answer this. So Danelle, we want to figure out for angle Y. So which triangle has angle Y in it? Tell me the three letters. Tell me the three letters of the triangle.
I could repeat that again, so sorry.
All right, so Danelle, I want you to look at. So okay, we want to find for Y, yeah? Want to find for Y.
Okay.
What angle is Y in? And I want you to tell me the triangle using three letters. Let me give you an example, right? You see this triangle? I would call the triangle SQP, right? So tell me, what triangle do you think angle Y is in?
RSP.
Great, RSP. So we're zoning in on that. We're locking in on that, right? RSP. Okay. All I think I can see how the button is going from here. I think I can see it. I'm gonna people in the Zoom.
Yes,
sir.
All right. So Danelle, remind me, what is R to P? What would I call that? Remind me, what is R to P? It passing, it going from one end to the other end, and it passing through the center. What would I call that?
The diameter, sir.
The diameter. What does the diameter do to a circle?
Make it a semicircle.
Right? What's the angle in a semicircle? Okay. What do you think this angle is?
90 degrees.
Exactly, right? So the angle in a semicircle is 90 degrees, right? Some of you understand that?
Yes, I understand that.
All right, so let me just make a little note about that, right? Angle in a semicircle. Good notes so annoying, right? Angle in a semicircle is 90 degrees, right? Cool. So then now, we know that this is 90, yeah? Tell me who it now.
Yes, sir.
All right. Do we know any other angles for this triangle?
18, sir.
So I know you have it in the bag. Tell me, how would we find for Y?
We would, okay, so we would add 90 and 18 and minus it by 180, sir.
Give me a damn day. Big up yourself. Big up yourself, right? So it could be 180, right? Minus the 90 plus the 18, right? And that should be 72. Somebody verify that. That's 72.
Yes, sir.
Yes, sir. 72.
Yes, sir.
Okay, good. So my answer is 72, right? Did everybody understand how I did that and how I used what was in the previous question to answer it?
Yes, sir.
Okay. Right? So the answer for Y is 72 degrees, right? 72 degrees. So the reason, what do you think the reason I'm going to put? What reason do you think I'm going to put? So
I think yes, sir.
Tell me, what rules did we use here? What theorems did we use? So zoning on this triangle, what did we use to figure out our answer? What were the steps? Remind me, how did we know that this was 90 degrees? How did we know that?
Because at the diameter, sir.
Yes, you had to say angle in a semicircle is 90. That was the reason, right? So
Okay.
angle in, don't put brackets, right? Angle in a semicircle, right, is 90 degrees, right? And from there, we also use the fact that the sum of angles in our what is 180. So I want to know, how did you know that you had to take it away from 180? How did you know that?
Because it's a triangle.
Exactly. So the sum of angles in our what? In our what?
A triangle is 180 degrees.
Right. Pick up yourself. So that's that. All right. Take that same diagram and move forth. So Z now. All right. Let me just put on the information we know, right? Then I'll have a question, right? If you know that this is 90, right? If you know this is 90, would it be
Yes,
hard
sir.
to figure out this angle?
No,
What is
no.
I know you could do it, figure it out. So if you know this entire thing is 90 and this piece is 54. So this piece is 54. What do you think this could be? You think it's an add, minus? What do you think it's to do?
Minus, sir.
Right? You're minusing the 54 from?
Yeah, from the 90 degrees.
Yes. Yes. Right? Good job. So maybe, in the next part, maybe if they ask you something where you could possibly, where you might possibly have to find for it, you know how to find for it, right? Cool. And just a reminder, this is 18 degrees, this was 36 degrees, and this was 54 degrees. Right? So that's all the information we found so far. Right? And we also found out y. What was y? Y was 72. So this next question is so easy, yeah? Real easy. Danelle, what do you think angle Z is? Okay, so I'll give you a hint right now. Let me go back to the circle theorems when he was learning it.
Okay.
All right. So Danelle, wait, 1 second. All right, so Danelle, look at this diagram, right? This angle D, it was standing up on what? It was standing up on,
It's standing upon A and B.
right? This angle over here was standing up on what?
A and B.
If you have two angles standing on the same arc or chord in the same segment, they are equal, right? So
Yes, sir.
keep that in mind, and I want you to look at this question, and I want you to tell me if you're seeing what I'm talking about. So they want us to find for Z, that's this angle over here. So let me ask that question now, right? What chord is angle R standing up on?
S and P.
Okay. What chord is angle Q standing up on?
S and P.
Are they in the same segment?
Yes, sir.
Yeah. So what do you think angle Z is? I check back the theorem. Check back the theorem. Right? Check it out. So I said if this was 49, this was 49, right? So
Yes, sir.
what do you think Z is?
72.
Yes, Z is 72. Right? So the theorem for this is a little long, right? So let's write it. So now, For me to use this theorem, both of them had to be standing up on the same what?
Chords,
Right. And need to be in the same what? What is this?
segment.
Right. So now we need to write that in words. So we're gonna say angles in the same segment. Try to finish my sentence. Angle in the same segment. What next?
Standing on the same chord.
Right. And I'm gonna add in something to that, standing on the same arc or chord. Are what? That's what E.
Equals to.
Yes.
Equal.
Right. Yeah. Right. And yeah, you finish a whole circle theorem question there. High five. Take off yourself. Right. So now you know.
Thanks.
So now you know a little more when it comes to circle theorem. Right? Feeling okay?
Yes, sir, I'm feeling better.
Nice. Is there anybody in the Zoom that didn't understand Y and Z? Selma,
I didn't understand something.
we didn't understand. Like where I lose you from? Part one.
The ones with the X and 2X and that type of thing.
I lose you there.
Yeah.
All right. So X, I want you to think of okay, in maths, letters are just placeholders for numbers. So letters could be any numbers, right? The thing is, we are trying to figure out what number it would be to satisfy the condition. It's something complicated, but let me show you something, right? So watch this, right? Check this. Remind me, what is this? What is O to P? O to P is called a what? What is O to P?
Radius.
Right? What is BA?
A tangent.
Right? It's a tangent. What is the angle between a radius and a tangent?
90 degrees.
Right, so you're with me so far, right?
Yeah.
Okay. Now let me ask that question, right? This angle here is 2x, and this angle here is 3x. For the condition to be met, right? These two angles here need to add up to what?
5x.
Okay, let me run it back again.
Okay.
What is the whole, what's the big angle over here? What's the whole thing? What's the whole thing?
90 degrees.
Right? So if this is the case, what do you think this angle plus this angle supposed to be equal to? Forget about the letters for now.
90 degrees.
Right. Say with me there, right?
Yeah.
Now, let me do this. Let me forget about the letters and just do it like normal, right? So, and if this was if this was numbers, you would have say like, okay, the number plus the number equals to 90. Did you do that?
Yeah.
Are we doing the same thing about letters, right? So I have a question. If you have two x's, right? Two x's, and you add in three x's to it, how much x's you have?
3x's.
Okay, watch this again, right? How much x's you have here?
2.
How much I have here?
3.
Okay. How much I have here?
5.
Right. You understand? If you have 2x and you add 3x to it, 5x.
Yeah.
So you're with me now, right?
Yes, sir.
So yeah, and you agree that this angle, whatever it is, plus this angle, whatever it is, has to be 90.
Yes, sir.
Let me put 2 and 2 together now. So we add in this. So this could be, so I'm gonna add these two, and they're supposed to be equal to what? When I add those two, it's supposed to be equal to
90 degrees.
All right, so let me do that. So I'm gonna say 2x, and I'm gonna add that to 3x, and that's supposed to be equal to
90 degrees.
right. So remember that condition I was talking about? We're trying to figure out what x would be so that it would work out to be 90. That's what we're trying to figure. So let me ask you a question. What is 2x plus 3x from what I just showed you?
It's supposed to be equal to 90 plus it's 5x.
5x, right? 5x. So 5x is equal to 90. You with me?
Yeah.
All right. Let me give you a logical explanation, right? Let me just say you buy let me just say you buy five what? Let me just say you buy five snow cones and it costs $90. How you not find the cost for one snow cone?
Divide it by 5.
That easy, right? And she just probably do that in your day-to-day life. Like if I come and tell you I buy two phones for $1,000, and she will be like, and then in your head you will be like, that's $500 for one.
Yeah.
So like, is the same thing here, you know? Is the same thing? If five of something is 90, what do you think you go find for one?
Divided by 5.
Exactly. And that is the whole gist of it, right? Another way to think about it is if you're multiplying x by 5 and you want to find for x, you need to do the opposite. So you will cancel off. So what is the opposite of multiplying something by 5?
Divided by 5.
Yes, dividing by 5, right? And if I divide both sides by 5 on the left-hand side, we're going to have more of those 5s.
It will disappear and I'll only leave x.
Right. And what is 90 over 5? What is 5 into 90?
18.
18. Now you're probably wondering, what is the significance of this 18? What are 18 doing? Like, how that even make sense? Let me show you how it's satisfying the condition. So let me plug it into what we have now, right? So we have 2x. What we know x is now. X is what?
18.
Wait, 2x means 2 by 18. What's 2 by 18?
36.
Right? Okay. And then we have 3x. That means 3 by what?
18.
What's 3 by 18?
54.
Okay, so you're going to be mind blown now, right? What is 36 plus 54?
90.
Everything makes sense, right?
Yes, sir. Thank you.
No problem. So x could be any number, but we are trying to figure out the number that will satisfy the condition, right? So 18 is that number because when x is 18 and you work it out, you'll get 90. So
yes, sir.
That makes perfect sense now, right?
Yes, sir.
Great. And you say you was confused about something else?
No, it was only that.
Okay, cool. Great. So, like, are you ready to move on to a new question now?
Yes, sir.
Yes, sir.
All right. So the person that I just did this with, right, the algebra. Let me do our next question. Let me do our question together. So give me a year. Give me a year.
To 2015 because it's right there.
Oh, you write 2015.
Huh? I said do 2015.
Oh, okay. I thought you said you write in 2015.
No, if that was true, I wouldn't be here right now.
June or January?
June.
June? I feel like we did already, you know. Or was it some? Let's see. Did I? No, I didn't do that already. Okay, it would look like there was no circle questions on that year. There was no circle questions that year. Yeah. So give me another year.
2018.
I feel like we just do 2018, you know. Let me see.
Yes, sir, we did 2018 recently, sir.
Okay. Give me another year.
2016.
2016. All right. Yeah, I have the answer here. It's a real nice.
Oh my gosh.
I tell you, like, I real do maths. As real do maths. Like, it's not even funny how much maths I do. It's like an insane obsession. Well, the obsession is really with helping people in maths. Sometimes I like maths, sometimes I don't like maths. It's like a love-hate relationship. Because maths go humble you real bad sometimes. Like sometimes I will be trying to be in UE. I try to do a question and I'll get real humble. So love-hate relationship. But the most important thing is you don't give up, right? So don't give up. Like you see, like I'm gonna ask that question, right? In the last question, and this X thing will probably make you and it'll probably make you feel to give up.
Yes, sir.
But like, was it that hard?
No.
No, like you see, this is like a big downfall in maths. People will see things and they will be like, it's real complicated. I just not doing it. But when you sit down and you actually do it, it's not that hard. Really not. So you could figure it out. So okay, let me start the question. Again, all the information that is here is already provided to us in the diagram, so we could continue. So in part one, we want to find angle EHF. Now, if I want to see how that looks like, where would I start from?
E.
And from I would go to where? Tell me, guys.
H.
And I would go to
F.
I would go to F. Right. So let's actually draw that. So E, then H, right? E, then H, right? I think I like to see the theorems here already, you know. Like this looking real familiar. Real familiar. Right? So probably need to draw a line. I'll take out. Right. So E, H, and then EH to F. Are you understand that? Let me know if you understand that.
Yes,
Yes,
sir.
sir.
So where is the angle? It's by EF or H.
H.
It's by H, right? The angle is always formed in between two lines, right? So the angle is here. This is what we want to find for, right? So guys, let me ask you a question, right? What would I call this? What is this? What's that?
Tangent.
Tangent.
Okay, so count how much tangents we have, right? That's one. What is this?
Tangent.
How much tangents do we have?
Two.
Two.
Do they start at a common point?
Yes.
Yes, sir.
Yes. So guys, if that is the case, what does it say about this length and this length?
They're equal.
Yeah, right? Oh, remember that theorem? Let me go back, right? And I did a example. Oh, remember this?
Yes, sir.
Okay, good, good. I'm coming back here, right? So guys, what kind of triangle would this be?
Isosceles.
Right, these are isosceles, right? And the reason for that is because you have two tangents from the same point. Anytime you have that, anytime you had a situation, right? Where it cuts the circle, here, they will be equal. So in other words, I would say HE is equal to what? HE is equal to what? Tell me, guys.
FE.
Right, HE is equal to FE, right? And if you have a triangle with two equal lengths, what do you call that? What do you call that? If two of the lengths are equal in a triangle.
We say my isosceles.
Isosceles.
Right. Right. A triangle with two equal sides. Right? Two equal sides is called an isosceles. Right? So that would make this triangle a what? How would I make this triangle? If we know that this side and this side equal, what would I make the triangle?
Isosceles triangle.
Yes, right? And what do we know about the angles for an isosceles triangle?
The two base angles are equal.
Right. Base angles base angles are equal. So guys, if we look at this triangle, right? This triangle in particular, right? So let me just do a separate diagram over here. Right. Okay. So FHE. So we know that that angle is 44. And we know that this and this, they are equal, right? We know that. We know that. So tell me, guys, how would I figure out for this angle? Now, this question kind of tricky, yeah? It really is kind of tricky because some people, and I want you to tell me if you're one of them, how much of you all would say that this is the base the base? How much of you all would say that that is the base? Be honest.
I disagree.
How much of you would think that that is the base for the triangle?
Me, sir.
Okay, but it's actually not the base, right? Because the base is, okay, in situations like this, right? I want you to think of the base as the one side that is not equal to the other two. So guys, you see how these two sides are equal? Yeah, you see how those two sides equal? Are they with me?
Yes.
The base will be the last side that's not equal. All right, that's an easy way to like constantly get correct. So my question is, if there's an isosceles triangle and we know that this angle and this angle is the same, how would I figure out for those angles?
180 subtract 44 divided by 2.
Do you all agree? 180 minus 44 divided by 2.
Yes, sir.
Yes, sir.
Right. And for anybody that's confused, again, anytime you have two tangents starting from a point where they cut the circle, right, those lengths are equal. If you have two equal lengths, that means you have an isosceles triangle. And for an isosceles triangle, the base angle, right? And how do you figure out what the base is? The base is the one side that's not equal to the other two. So in other words, this is the base. So the base angles will be this and this. They have to be the same. They're equal. So in other words, these two angles are the same. So if I take away 44 from 180, right? These two angles will share the same angle. So I'll divide the remainder by 2. So it's 180 minus 44 over 2. All right, what are you guys getting?
Okay, 68, sir.
68.
Right, 68. That's the answer. And could you all mention any reasons we used? Tell me, guys, could you all think of any reasons that we used?
Tangents from a common point would be equal.
Right, we use that, and that's actually how we got the isosceles triangle. So for this one, I'm going to write a couple of things, right? Number one, right? So somebody call it out for me. Right? I want to see.
Tangents from a common point are equal.
Right? Tangents from one point are equal. And to make this statement solid and correct, what do you think I'm going to say? Be specific. What do you think I'm going to say?
HE equals FE.
Right. I'm going to say HE is equal to FE. And if that is the case, we would say that triangle HFE. So you can say, therefore, triangle HFE is an isosceles triangle. So let me know if you're okay with the reasoning we used.
Yes.
All right. If there's anybody that's confused, tell me. No, I don't mind going into over. Right. So let me just all right. That this is the base. This is the base. Right, that's the base. This is base. Right? So everybody quiet. So I guess all they understand this, right? Okay, cool. So guys, let's figure out FGH now. FGH. So one moment. Let me just take a screenshot of this. Take screenshot, copy. I honestly think that there isn't a single, like, okay, when I post this video on YouTube, I don't think there'll be a single video on YouTube that is as comprehensive as this. I feel like if you don't know circle theorems at all, like this video will be like the end, like gold on water, right? Because like we went through every single thing today and like in extreme detail, right? So like this is another frenzy video on thing. Don't be stingy. If you know they need help, don't hide it from, don't gatekeep, right? Yeah, so what I'm going to do, right? I'm going to put on the information we just found, right? So what do we know this angle is? We just found it.
68 degrees.
That's 68, right? And this is 68. Okay, nice. Now we want to figure out FGH. If I want to figure out where that angle is, where would I start from? Where will I start from?
F
Then I would go to G. Then I would go to H.
and H.
And the angle is formed in the middle of the two lines. So FGH. So starting from F, so FGH. I need to draw a little thicker. F. So can you guys see where the angle is?
Yes, sir.
Right. Is by what letter?
G.
Is by G, right? It's by G. Okay, great. So it's by G. Do I have any volunteers? Can you all see anything right away? Like tell me guys, what is FG? FG is our what?
Diameter.
Diameter.
So here what I would recommend. If when on this see a question, guy, just try to find for as much information as you could. As much information as you could. Right? Because simple thing is this. When you look at this triangle, isn't it in a semicircle? Yeah or no?
Yeah.
It's in a semicircle.
Yes, sir.
And we could figure out this angle here one time, like real fast.
Yes, sir.
Yeah, we could do that. That's not hard. And you might probably be wondering how that gonna help now. Right? Watch this. So at the start of this question, if we're looking at this triangle, right? How much unknowns we have?
Two.
Three. Things real bad. Real bad. Are we going through it right now? But we recognize the semicircle theorem, so we put 90 degrees here. Suddenly we only have two unknowns. So tell me guys, is there any other angles we could easily find for?
Angle F.
We can find for angle F, right? Just remind me, what is O to F called?
Radius.
And what is this called?
Tangent.
What is the angle between a radius and a tangent?
90 degrees.
Yes. I'm just putting labels here. So this is our radius. Right? That's our radius. Right? And this is our tangent. This is our tangent. So the angle in between is going to be 90. So guys, if we know that, would it be that hard to figure out for this angle?
No.
No, sir.
No. How would I figure out the purple angle?
Subtract the 68 from the 90.
Right, 90 minus 68. What's 90 minus 68?
22.
22 degrees. Let's go. Right? And suddenly, guys, how much unknowns I have now for triangle FG? One. And do we like when we have one unknown?
Yes, sir.
Yeah, because that means we could easily work with it, right? So here what I'm gonna do, I'm just gonna recreate this this diagram, right? So you can clearly see what's going on. So this is G, guys, right? So that's G. This is H, that's H. This is F. We just found that this was 22 degrees. All right, we just found out this was 90 degrees. And well, to find for G, we would have said 90, or same, we would have said 180, right, minus open bracket 90 plus 22. Is everybody on board with me in saying that?
Yes, sir.
Yes, sir.
What would you guys get? What would you guys get?
68. 68.
68 degrees. Now, that brings me to something, eh? I'm going to show you something, and I'm going to be mind blown. Because I remember the very first time I was doing this question with my students, I did not see it. And I do all of this working. But let me show you something, right? Let me show you something. When I show you this, all they're going to be like, what? What is it? Put that back shortly. If we know that this is 68, right? And we have a triangle here, and we have a tangent here. You see what I'm talking about? Are you seeing that?
Yes, sir.
I wonder if you're seeing that. The angle between a tangent and a triangle is equal to the interior opposite angle. So you could just find the answer like that. But the first time I did the question, I actually did what I did here. I did all of this working. Yeah, but which one would you guys actually see in the exam? Be honest with me. Which one would you guys have seen? Would you all have seen that you
The
could?
long working.
You working for
Yes,
sure.
sir. The long working.
I will put on both. I'll put on both working, right? Because like I know I want to keep that to all students. I know some students wouldn't want to do all that, right? But can we all agree that the long working is like the most straightforward thing? Like nothing hard about that. Like this 90, right? This 90, so you just take it away. Nothing hard about that. That's actually straightforward. But the short way would be much more convenient, right? It would have been a lot more convenient. So let me just take a screenshot of this, and then I'll put down the alternative solution. All right, so let me just take a screenshot of this. Put this over here. Right, guys, don't worry. Yeah, like when I send on the PDF on the WhatsApp chat, you'll be able to zoom in and the details will be preserved. Don't worry. Everything will be there. Right. So that's one way you could do it, all that. Or you could do the smart thing, right? We know that this was 68, right? We know that this is 68, right? We want to figure out for this angle, right? So we're looking at this triangle. Okay, can you guys see the rule now? Like, let me know. Can you all see the other theorem we could apply? Let me know
Yes,
if
sir.
you all see it.
Nathan, no let me surprise you still live there.
Hey, I go in as long as these students want help, you know. I go in. I had the math vibes energy, dog. I had the energy, dog. That energy day, that energy locked in. Right? I have an energizer bunny inside, I don't know. That's somewhere.
Man,
Like
man, have the energy, boy.
I don't know where I get this energy from, you know. But guys, can we see that we have a tangent over here? Are they agree? That tangent?
Yes.
Agree.
That tangent, right? And what is this?
Triangle.
Right angle, triangle.
Yeah, that's correct. You could say a right angle triangle. This is 90, yeah. But guys, isn't the angle between the tangent and the triangle equal to the interior opposite angle?
Yes, sir.
Yes, you
Yes,
can
sir.
just do that if you want it. But I'm being real honest with all you. The first time I did this question with my students, I didn't see this. It wasn't my immediate thought, right? But yeah, but both forms are working. Take screenshots, copy, right? Paste, right? Method 1 or method 2. Right. So guys, in the interest of time, I'm going to put on the reasoning for the second one because it's just one theorem. It's just one theorem, right? But tell me, guys, if you had to state like do little statements, right, for the reasoning, would you have trouble with this? Tell me, would you guys have trouble with this?
No, sir.
No? All right. What would the first statement be? Somebody, what would the first statement be here?
The
Actually,
angle between the radius and the
right? So, yeah, angle between,
the tangent is 90 degrees.
right? So, Nikolai, let some people talk. And I feel like you ready to mash up this maths. You ready to cop down this maths. You have it in the bag, right? I got let somebody well we kind of maths answer. So a girl was talking, right? You were saying that the angle between,
I was going to say the first one that we write down is the angle with the semicircle is 90. That's the first one that we found.
all right. So you would say angle in a semicircle is 90 degrees, right? And what else you would say?
The angle between the radius and the tangent is 90 degrees.
Right, angle between radius and tangent is 90 degrees. You'll say that. And lastly, we'll say sum of angles. But also, like you see, there's a lot of reasoning you had to say, boys. That's real reasoning. Some of like the last one optional, but still it's plenty reasoning. Sum of angles in a triangle is 180 degrees. Like it's not hard, it's just real reasoning. And what was the theorem for the other method? Somebody tell me.
The angle made between the tangent and the side of the triangle is equal to the interior opposite angle.
Right, so the angle between the tangent and triangle is equal to the interior, right, opposite angle. Yeah, let's go. All right, let's go. So I'm gonna put this reason in here, like in the interest of time. Right? Actually, I'll just forward you guys to this and this because I have everything over here. Are you okay with that? I'm gonna follow you. Good with this question. Question 2.
Yes, sir.
Okay, cool. Let's handle part 3 now. So JHE. JHE. So where would I start from? Somebody tell me first. I would start from
J.
then I would go to H, then I would go to E, right? JHE. So I'm gonna start from J, right? J. I'm gonna go start from J, then I'm going to go to H, J, H, and E. So guys, where's the angle? Where is the angle?
H.
H. H is the angle. Right? So we want to find for angle H. Let's put down all the information we know, right? Right? Let's put down all the information that we know. So we know that this entire thing is what? What's our entire thing? Reminder? What did we
68.
68. And we found that this entire thing was
8 as well.
yeah, because it was an isosceles triangle, right? We found out this was what?
22.
That was 22 degrees because 68 from 90 is 22, right? We said that this was 90. So I just listed all the information we know, right? And we found out this was what? What did we find that angle to be?
68.
Yeah, we found out that was 68 degrees. Right, so we need to figure out this angle. All right, do any of you guys...
The theorem. We could use a theorem.
Which theorem you want to use?
The same one that we just said was around the angle between the radius and the tangent.
All right, so you want to use, so this is the radius over here, and this is the tangent. So this is what you want to do?
Yeah, because they asked for JHE, so it would be 90.
Actually, wait, let me just verify that. So this is the radius here.
Yeah, and that's the tangent.
Oh, well,
So
okay.
the theorem one time.
Yeah, that's correct. Like I was gonna do real work, and I'll be real honest with you. I don't lie, right? But yeah, I see it in real obvious now. Right?
Yeah.
The radius is the tangent. Bam. A marks one time. Yeah, right. Good job. I did real good. So like, just to reiterate that, right, guys? Reminder: if you have a radius and you have a tangent, what is the angle between the radius and the tangent?
90.
90. So we want to figure out this angle over here. So that would just be 90. That's it. Right? Great. So that one real easy. The answer for this is just 90 degrees. And the reason is just angle between radius and tangent. Right? Radius and tangent is 90 degrees. Yeah. Hey boy, I real proud of you. I'll come a long way. Like real far. So for the working, I can erase everything, bro. Like I really didn't need all of this. Right? I'll just be 90. Yeah. And I'll just label this a radius. Right? So I'll label this as a radius. And I'll label this as a tangent. Right? Cool. And I'll put a screenshot in. Right? Right. Paste. Okay, cool. Last one, JGH. All you know how let's go by now, right? So we're gonna start from J, then we're gonna go to G, then we're gonna go to H. And that's going to show us where our angle is. So J, G, H. J, G, H. Right. So J, G, H. I'm probably laughing. That real easy. That real easy. What's the answer, guys? What's the answer for that?
It's in a semicircle at 90 degrees.
Yeah, that lightweight. That is nothing. That food. That is food. Right? 90 degrees. Right? Angle formed in a semicircle. $90. So guys, we did 3 circle questions and we went through all the theorems. How are they feeling about circles now? Like after the live, are they gonna practice circle theorem to make sure you don't go rusty?
Yes, sir.
Okay. That's all I advise you to do it because like as much as you learn today, it's gonna be pointless if you don't do anything, if you don't do any work by yourself. It's gonna be absolutely pointless because it's not gonna stick in your brain. So guys, practice, practice, right? Yeah. All right. So it's 10:50. I real hungry. I been real hungry. So let's have our energy. Let me know,
Yeah,
guys.
not that much, but still the energy.
Of 50% right now.
Okay, I had to get the if I give a little break, right? A little break. So we did work on circles, right? We did work on
So you
circles.
know my chance I fall asleep and I get back up, but I understand everything.
Yeah, boy. I'm happy that you understand everything, right? We could take like a 15 minutes break. And when we come back, I want to do our paper 3. So those who do in January, right? Or those who interested in maths in general, right? Or they could wait, or they could take a little break and thing, and when we come back, we're gonna mash up that paper 3. Right? Yeah.
Okay. So
All
we
right.
coming off, we signing off, or stay on and just come back in 15 minutes.
I can stay on and come back in 15 minutes. Yeah. But like,
Don't fall asleep in the 15 minutes.
Need to go get some coffee.
yeah, go get some coffee, right? The paper tree not long, but I think it'll take a little while for me to explain the concepts to you guys because like I feel like a lot of you might be a little rusty. That might be anything, but it's not that hard. Yeah. I keep saying things not hard, but like the person who had the problem with the X, and you thought that was hard? Like I could have swear, you could have swear that was hard. And like we do it on the way,
Yeah.
right? Most things not that hard. Right. So I'm gonna give a time to come back. Oh, I see somebody ask me earlier on the Zoom meeting, right? Somebody asking me on TikTok, sir, what is the best Casio? Are you excited? So what is the best calculator to use for CXC maths? Casio or Sharp? I want somebody to tell him the answer.
Casio, darling, Casio.
Sharp is not even an option.
That's not even an option. Why you even considering a Sharp, right? And if you
You
can't
shop to cut your ham for Christmas.
say that again?
You need to use sharp to cut the ham for Christmas.
Hey, that's a real good one. That's a real, what's your name? I'm gonna write that down in the notes. I'm gonna quote that. Right? I'm gonna quote that.
Michelle said,
You need
use a sharp
use
to cut your ham for Christmas.
right to cut. And you don't think that thing though, I should not even know.
That bad. What they say there, boy?
I know, right? These people have
A sharp to cut your ham for Christmas.
Backside.
So you need to use a sharp to cut your ham for Christmas.
Now you making people decide whether they're going to buy a Casio or a Sharp now. A Sharp going to be in season.
Boy, I telling you, right? Like, I think Casio should put me in business as a marketer, honestly, right? I think I'll take a good marketer, right?
Come on.
Right? And what's your name? I give you credits.
Michelle Shepherd.
Say that again?
Michelle Shepherd.
Shell as in Shell?
Michelle Shepherd.
Oh, Michelle. I was hearing Shell, right? Michelle. You tell me if I spelled Shepherd wrong.
Correct.
All right. At Math Vibes. Yeah, somebody take a picture of this and put it in the chat. That's real funny. That's too funny to hide, to keep away. Wait, let me just pass sticker here. Wait, just handling the vibes here. Give me a second.
That is so funny.
Actually, I prefer it without the bubble. Like that look cooler, that look tougher. You know, that look tough. Yeah. I take a picture of this one.
We're gonna need a sticker now with a sharp in the middle of a ham.
Yeah, boy. Hey, I gonna ask ChatGPT to do that now. Well, hey, Ollie, I gonna do that now, right? I gonna do that now. Oh, that gonna be real funny. Let me do that. Right. Generate a picture, right? Of a sharp calculator, right? Cutting a ham. But the thing is, guys, I doubt it even going to do a good job at that too, which speaks volumes of the use case of a sharp. All right, so guys, stay tuned. ChatGPT gonna generate a picture of a sharp calculator cutting ham. I'm real curious to see what they generate. I'm real curious. What is this? I'm real confused by this. Let me show you what chat come up with. Where did knife come from? Now I want to know where did knife come from. Bro, what? Let me ask ChatGPT.
That's what retarded boy over here.
Wait, let me. You don't say sure. Wait, I'm talking in ChatGPT. You don't say sure. Where did knife come from? Come from. I don't talk to anybody else like this, eh? I just talking to the AI. Like, I promise I'm a nice person. I promise. Wait, we're going to get down to the core of this. All
Yo.
right, it generates on a picture. Let me see what we're gonna do this time. It generates a knife again. ChatGPT. Wait. Where the knife coming from? Where the knife coming from? Where the knife coming from? No knife. Use the sharp as the cutting tool. Here, sharp calculator. Sharp calculator. Let me just copy this image. 1 second there, guys. Right. Yeah, let's see what we come up with here. I think ChatGPT will be right this time. We go see.
I highly doubt.
We go see, right? But the thing is, ChatGPT like this real sensor things, right? Real sensor things. So like I surprised it showing knife. Like I real confused.
Well, it's a knife in a kitchen utensil and also ain't really censor that.
And they do the maths wrong too. This is preposterous. Like bro, it said sine 99 by tan 99 is minus 62360. What even the AI know sharp dumb. Even the AI know that. Let me show you what the AI come up with. Watch this, eh? This is what you come up with the second time around. Are they going to bust out laughing? Are they going to real laugh when I show you this? Trust. Like even in ChatGPT version, I can't do maths right. What? Are you seeing this? I can't be the only one like flabbergasted here. How is sine 99 by tan 99 negative 6 quadrillion something? What?
Well, at least you get it sharp cutting into the hammer. Can't complain.
I guess so. Yeah, no, I can take a picture and thing. Don't forget to tag, man. Yeah. Big up Michelle one time. Michelle, use the goat. All right, use the goat. Wondering what to eat, boy. Are you have any suggestions also what I should eat?
We only have 5 minutes left in the break too.
I feel like, you know what? See this digestive I was going to give all in? I'm going to eat it. Yeah. Sorry, I have more digestives. Just on like cardboard. I love digestive though. I go wrong with digestive. Oh, you know it's on mukbang? You know, like where people is like eat food, like on the camera. Oh, you know what I'm talking about?
Actually, yes.
Yeah.
Wait, I doing that right now. Yeah. I had to get him mic to do the ASMR too. Right. I have a question, guys. Any of ladies who like editing and thing? Because like I want somebody to um like you see all these funny clips and thing, yeah, real funny clips in class. I wanna like compile it and make a TikTok.
That's real loud there, boy.
Yeah, boy. I hear any for kids. Come on. I could give you that job because you do editing.
Yeah, just do that.
And you know exactly. Right there. I'm flip the camera. Yeah, and so on, like you have some free time now. And you're real funny yourself, so you will find real funny moments, I'm sure.
Oh boy. I could imagine the kind of nonsense I go find. The kind of nonsense I go do. Oh gosh.
Taking a commercial break right now.
You can't leave the butter.
Hey, Tivana, the cat lick the butter. Wait, what, Tivon? Waiter. The cat lick the butter and Budlal watching. Tivon, finish it. Finish it.
I don't know that time is just that piece I eat.
So that's the only piece you know.
Yeah. That's what you've been used for a long time. Some of them. Remember that?
Yeah. The video where I explain fractions using the butter.
Yeah.
Yeah. Yeah, Shiva, the cat lick the butter, boy. Tell no more butter. So I can't make butter and bread. Hard times. Yeah, Tivon, and you tell me I'll be sleeping by now?
Huh?
You tell me I'll be sleeping by now?
Right. Still he doing work, boy. So I ain't sleep as yet. I thought I would, but and I still have set up until like 12 because I take a meditation for that time. So might as well just set up until that.
And your arm okay?
Huh?
Your arm okay?
Again, a little bit that.
Okay,
Doing back my normal chores now, but it's still limiting to some extent.
question. When it heals, do you think you could beat my enhanced strength?
No. Not at all, boy.
I like a real sleeper, but you know, like if you look at me, you'll think I got weak, but like I know like I'm surprisingly strong.
This man really don't look at this man and say, hey yo, I could beat you in a hand, understand? This man go ring, this man go mash up your hand. I want all the young men in this library now who feel like could to with the teacher. Teacher go mash up it. Watch his son.
And the thing is like Devon much bigger than me, right? Like he's much taller, like he look buffer. He look bigger, you know, like but like it's interesting. Devon, my girlfriend, trolling any chats. She said we could see your hair, bro.
TikTok chat? Well, I don't have TikTok open, so I can't see it.
Somebody said, so you have any video on Casio calculator tips? Yeah, or tomorrow I'm gonna make some video tips. That's the plan tomorrow.
Tomorrow during the live session or tomorrow in general?
In general, I'll make a video.
Okay.
Timon, like you surprised how much people they still have like I kind of surprised like they still have close to 20. It's crazy.
Them man want learn the maths, boy.
Wait, I'll show them here. See?
I put them before me now, them man come to me before me now, them before me about it.
Yeah. For a second, I thought I was going ball, but like, I'm trying to take care of my hair. Trying to take care of
You go ball, you know, boys. And see them man trying to make you go ball already.
Boy, you will make me go ball. Like, I can do this maths thing. If anything, doing this maths thing would make me grow back here. You will make me go ball.
So teaching maths go make you grow here, and not teaching maths go make you grow ball.
Yeah.
So that means
Actually, most engineers just go bald while they're learning in engineering.
no, but
So it's like a rite of passage.
this guy ain't learning, teaching. So this is what he don't know.
Like my hair.
So he does grow here while he teaching. When he learning is when he does lose it. And that probability.
No, but hear this, eh? I have it bad on both sides because, like, most maths teachers, they're fat, they're bald, and they are unk status. If you know, you know. And engineers, bald, and there's the coolness.
Oh gosh, I want to mention the homeless part there, right? I feel sorry for some man look at them, but gosh. Oh, it's funny.
By the way, guys, by the way, don't forget the YouTube channel. Wait, stop shit. Yeah, guys, don't forget this, eh? Don't forget this. The YouTube channel, go subscribe, guys. If all
Close to 1K.
Long time I don't do that already, sir.
Big up all yourself, right? Go subscribe.
Close to 1K. 1,000 is a crazy amount, you know.
Tivon, let it drip. You gotta be like, follow the man on all of the media. You know what you just said.
Follow the man on all the media. I want to make you feel generous.
Right. That's what he's talking about. But like Tivon, I don't know what's going on. I find like I'm looking buff. Like I find I'm looking all buff. Like
Sir, doing maths making you feel buff, sir? Maybe I should do more maths.
apparently, like what? Like I looking a little buff.
Maths.
Like I went.
No, but sometimes the maths is hurt your brain more than make your muscles, you know. So
I'll be honest here. Yeah, that's happened sometimes.
The maths are giving keratin.
Better. Like right now in UE, I'll be real honest with you. The course I think I did the worst in is maths. Honestly, all the other courses I probably get like 90 something.
You
So,
imagine that?
real.
Hard to believe, right?
All right.
That's the level. Why I don't know. That's the irony that it's crazy. You don't think?
Boy. And if it's one thing you shouldn't be scared of admitting moments of hardships or like you shouldn't be proud. Like, okay, like, you know, if I feel that maths course is on the end of the world, I could always write it back and get like 90 something.
yeah, but you just had to pay for that. You just had to pay to run.
Yeah, okay. And it does be expensive every time you rewrite it.
But you know the thing is, right? The thing is, success doesn't come to people that give up easily. Like you can't if you encounter a hardship, you just have to keep going. You gotta keep going.
On the hardships, man, on facing in this course, boy. Especially man like me, boy.
Time is 11:11. I'll make a wish, make a wish, make a wish.
11.
It's the past CXC right now, sir.
Later, I wish for you. Don't worry. It's in the math god's hands, right? Imagine the math gods above saying 6-7. That's crazy. That's crazy. I didn't think about that, you know. Imagine that's what
Yes, sir.
right now. Imagine that is what the math gods doing right now. That's crazy. I didn't think about that, you know. We learning some mind-bending stuff today. Wow. Yeah, so Nikolai, a senior from the 8th of January.
Yes, sir.
Ah
You'll be
boy,
sure we did.
boy, let's go. Right? Because like after the 24-hour marathon, I taught you to jump ship and I come like in the classes because like I see I had real potential and it was real curious, like it was real into it. Yeah. But it's okay. I'm happy to have it now.
When you plan to do that 72 hours,
Okay. Here what
it's 7. It's 48. Please have read my mind going.
Yeah, it's 72 hours I want to do. I want to do 72 hours a month.
When you get into that season, you have time.
Well, I need a new laptop first. This laptop I have right now, it's sticking like butter, boy. It's sticking like butter.
600. So you're doing 48 and then you're doing 72.
Yeah, boy. I
So
plan
we're
on
doing 48.
I plan on having you over, right? So you might come over. Yeah.
All
So
that we have to talk about now.
like you
All
might
that we have.
yeah, butter does stick. I don't know what butter you're talking about. You had to heat up butter for it not to stick. Yeah. But yeah, I want to do 72 hours.
When do you think I'm doing that? Next time for the next CXC or something?
Well, January probably. School opening on the 19th. So might dedicate 2 days doing it before school. But like I want to do like a whole inspirational video leading up to it.
So you just say school opening on the 19th?
Not opening on the 19th.
For me, UE.
Oh, I was not gonna say that extra days for me.
Yeah, 19th. But I have to register for all the courses, sort out gates, all of this stuff. Real thing.
If
Um,
it's one thing with
Michelle,
this thing
if it
is
on.
Yes.
Oh, somebody put a camera on by accident. It's okay. Happens to the best of us. Hmm.
if it's one thing with you,
So
it
I'm
will
not putting on my
show.
camera again, no, sir.
Why? Why?
Remember that Dragon Ball Z, you think more about that Goku thing? Nah, I'm not putting on my camera again.
Goku thing? Why tell you? What did I tell? Why tell you? Why
You
tell you?
talk about Dragon Ball Z when I pull up the calculator. Yeah, I'm ashamed for days now.
Let me see. Like, put on the camera. Put on the camera.
I don't think just now.
Because like I just feel bad with my camera. As you when you put my camera on, I feel a little bad. If I want to like make me feel a little less bad, you know, like
Yeah. Oh, yes, sir. I still have it. I still have it. Nothing, sir.
yes, it coming back to me, coming back to me. Yeah, it coming back to me. Coming back to me.
Yeah,
If
so
we haven't tell
I'm
the
not putting
man, boy,
my camera.
the man shame for days.
So here we're gonna do it. I'm gonna end this recording. We're gonna start a new recording, right? So
Yes, sir.
if you're watching this video and you reach to the end, type vibes in the YouTube comment section, right? Or you have anything to say to the people that might be watching this live? Might be watching the
Just keep
video.
grinding, yes? Because if you don't grind,
Wait, you live on YouTube too?
Yeah, I got this gonna be on YouTube. I'm gonna post this video on YouTube.
Oh, the
yeah,
video, the
it's
after
boring.
video, I think you're live on YouTube and TikTok and Zoom.
I tell you, my laptop hold on my back, boy. As soon as I get my new laptop, I gonna be streaming on everything. Twitch, YouTube, Instagram, everything at the same time. I gonna be all over the place.
Yeah, learn a bit about Twitch before you decide to jump into that one.
Yeah.
You can't just jump into that one because they might ban you instantly. But it's
Yeah.
not as lenient as YouTube and TikTok.
Well,
So do some research into that before they jump in, before you decide to use that as a platform.
all right, I will see. But yeah, I'll have anything to say to the people that might be looking at this live.
Remember, and like and subscribe. Don't just watch the video and just subscribe.
Do maths, it will benefit you.
Anybody else?
Oh.
Based on the silence, I take it not. I'm gonna end this recording, right?